So obvious, right? Okay. As you're aware, there are a variety of apocalypses, or I don't know what the plural of apocalypse is, but anyways. Yeah. Yep. Anyways, okay. So you all did this, right? We all shod. We didn't shy away from the Shah. Okay. What follows SHA 256 is, in theory, I claim at this point in time, you know how to make computers do things with numbers. That's my claim, that after SHA 256 you can make computers do things with numbers. And you're probably thinking you're pretty smart, huh? Right? I remember the first time I made a computer do things with numbers, I was like, I'm a genius. And I hate to point out to you at this time that you only did addition, right? And so while there were 256 bits, and that is in fact a relatively large number of bits, that is many, many smaller bits than you need for many cryptographic applications. And separately, you also have to do this thing that is slightly harder than addition, called multiplication. And then there's this thing that's way harder than multiplication, called division, that feels impossible the whole time. It's one of those things that feels impossible until you did it, and you're like, guess it works now. And the way you find out it works is the extensive testing script you had to write to have any chance of ever finishing this suddenly starts returning yes, and you don't know why, right? So that's division, and that's right here, 496T. So that's the assignment that's going out now. If you are making amicable progress on SHA 256 and haven't finished yet and want to keep working on that for your own learning, you should feel welcome to do that, and you should feel welcome to do that for a very specific reason that is anomalous, which is that these intermediary number theory lectures, as we build up to the Fermat lecture, which introduces RSA, these number theoretic lectures support all forms of low-level computing. So they support both SHA and RSA. They're sort of just the background knowledge that I think you would benefit from having. They introduce things like vocabulary, styles of thinking, things of this nature. So unlike as soon as the Fermat lecture goes out, you should drop everything and start doing RSA as fast as you can. That is not true yet, right? Finite, BigNum, BigAdd, LibGMP, 4096T were all an original super lecture that was dramatically too large to give in a single context. And so what I'm going to do today is I'm going to start at the beginning of that super lecture and just begin to progress through it. The thing called Finite right now was originally a subheading in the thing called BigNum, and that was how far I got on the first day of class. So there's no right or wrong amount of time to spend getting through this stuff, but depending on how far we get tonight, I'm going to look at what we missed, try and take that out of the remaining part of the course, and then start us on Fermat next week. So we're going to try and launch 496T no matter what, with the understanding that division is hard no matter how prepared we are. So that's my course plan. I'm going to start on Finite. Now, depending on what happens, I might refactor this website and put things together and move headings around so you can look back at it. And I will probably have to do the same thing I did this week as I did last week, where I made a number of corrections to the hashing slides. So those are all logically correct now if you go back and look at them. So I think I took out all the mathematical errors, right? I don't know if you go back and look at all this stuff, but it needs to be correct for my brain, so it doesn't matter. So as we progress through Finite, BigNum, BigAdd, LibGMP, and 496T, there could be movement on this website just to support you being able to look this stuff up and treat it as sort of the reference material. I met today with Professor Aaron McNicholas, who is our top number theorist at Willamette, who taught actually an RSA class just called number theory. So it was not called cryptography last semester or something, and just talked about this. It seems like I'm not entirely off base from a mathematical perspective in how I'm teaching this, and I'm relatively confident I'm teaching it from a computing science perspective correctly. But it does remain the case I haven't seen anyone that ever tried to teach both these things at the same time before. So I don't know how weird it's going to get. The reason to motivate the I don't know how weird it's going to get is it could be the case that I'm talking about a bunch of things that we understand, and then suddenly I just hit some 400 level math topic you've never heard of before that I happened to learn in like a 100 level CS class, because this does happen where your 100 level CS professor just happens to teach you a little bit of some topic because it's useful at the time or something, right? And mostly in my undergrad that happened to me with like, for some reason really early on I learned how to like construct the reals out of sets, which is like not anything anyone does. And I don't know exactly what your background is, but just stop me if anything gets too weird. I don't really trust the Salem students would have stopped me if they saw weird things, because a bunch of them that took the number theory class sit in the front row and tell me to go faster. So that means that unlike SHA 256, where they were all clawing their eyes out and screaming in agony and telling me to slow down and finding bugs in the slides, they all just sat through the Finite and BigNum lecture and were like, yeah, this follows trivially from ZF set theory, which is in fact true, it does follow. So, without further ado, let's look at finite numbers. So, the reason this thing's called finite, it was originally called BigNum. And the motivating anecdote for this was actually from like maybe my first systems programming class. We'll begin with an anecdote because it's helpful to organize this. My computer science education, I took 10 weeks of Lisp, and then I started in C. And the thing I learned in Lisp was data structures. So I essentially learned all of the recursive data structures and hash tables, and in fact, you don't need anything other than that. Thank you, Haley. That was good thinking. That's creative problem solving. That's computer science, actually, right? That's the only computer science we're going to do tonight, probably. Okay, so this is unusual. This is no longer the way things are taught. Even my university now teaches exactly 20 weeks of Python and then starts C, because all of the things that you get out of learning Lisp, you can learn in Python, and you can also learn to do machine learning. So it's like, okay, so we spend twice as long. But what that meant is that a lot of my theoretical computer science background was actually taught in C, because you're not really done introducing things like what a for loop is in 10 weeks, right? So the first for loop I ever saw in my life was in a C programming language. Until then, I had only written recursion. And so I did a few weeks of that and basically discovered what segmentation faults are, which I should have successfully protected you from with the form of instruction I'm using this term. And then I got passed from the programming language theorists to the systems programmers, and I took this class from someone named Ian Foster and Gordon Kindleman. And their names are significant because I didn't realize this at the time. I was just sitting in class bored and thinking they weren't particularly good teachers, which they weren't. Then I looked up how many academic citations these guys have, and I do believe now, having read the papers and many more years of education, that Ian Foster did in fact personally invent the internet. Like, someone did, right? And I read this paper and I was like, this paper is the internet, right? So I think like maybe Ian Foster was like really famous because he like invented the internet, and I'm not sure that like he knew this or like no one told him, right? But like pretty interesting person who seems to have invented the internet by accident and not taking credit for it. And this is in contrast with the large number of computer science faculty that claim to have invented the internet and did something like invent TCP/IP packets, which is like a very, very easy idea, right? Ian Foster was interesting because he talked a lot about how big the numbers in computers were. And there was something that was very important to him, and it's important to you all, and we've talked about this, where the numbers in computers, if you keep adding them together, at some point they don't keep getting bigger. They start getting smaller. And this bothered him a lot, because there's a finite number of bits in your computer, so eventually you have some overflow. And the numbers that you don't overflow, eventually at some high probability will give you back a smaller number. He hated this, and I realized now he hated this for a very specific reason, which is because this guy invented the internet, which means he invented IPv4, which means he made a huge mistake, which is he thought there were going to be 2 to the 32nd devices connected to the internet until the end of time, because that was the biggest number he had access to. And, you know, in C89, right, because they didn't have the 64-bit integer standard at that time, right? And he was a C89 programmer, as am I, because I took his class, right? And so shortly after inventing the internet, he spent every single waking second for the rest of his life wishing he used more than 2 to the 32 to describe the number of internet addresses, right? this is like such an unusual idea that like a lot of times, right, when we pick the wrong integer size, we go back and change the code. And you can't do that if you're the person that invented the internet, right? And in fact, since like 1995, they've been trying to switch to IPv4 or IPv6 and have 128-bit addresses, and in fact, you still cannot use them. I'm using our least favorite operating system here, Microsoft Windows. Can I hear some loud booing from Microsoft Windows? Yeah, that's what I thought. Okay, good job. And if I just ping something, well, let's do like an IP config. Does anyone know how Windows works? If I type reset here, what's it going to do? Oh, I don't want to turn off my internet. Well, let's just hit IP config. There we go. So that is a link local IPv6 address. And there's the actual IPv4 address I have to use. And then here's the subnet mask that allows me to connect to a part of the internet, and then I have to map my IPv4 address to other addresses and other parts of the internet, right? And I have this for all of my various network adapters, right? I have local IPv6 addresses, and this is that expressed in hex? That's what that is, right? So that's a 16 bits. I don't remember how to read IPv6 addresses. This is not a networking class. I'll teach one of those next year and I'll refresh all this stuff, right? And here, this thing is representing 32 bits, which you can tell because 255 is strictly less than 2 to the 8th. So these things, that's 4 bits. 4 bits added up together is, no, 4 bytes added up together is 32 bits. So there's 2 to the 32 of these IPv4 addresses. And that's just not nearly enough. I myself actually have 2 to the 32 devices connected to the internet. So this was a big mistake. And then the next question I ask students is, about how much bigger is 2 to the 128th than 2 to the 32nd? Lots bigger, right? Because what the students always want to say is 75% bigger, right? And in fact it is. It is 75% more information, or 2 to the 96 times bigger, right? So it is much bigger. If you're like me, you have you heard of the term chronically online? Yes. So I have been described as that way, and my partner's coworkers have reached out to her to ask, am I chronically linked in? Because apparently I post too much on LinkedIn. So that's how bad it is for me. People think I'm chronically online on more than one specific website. One student in my class suggested that I get a letterbox the other day because I was talking about Nosferatu 1922, of course, the good version of Nosferatu, right? I think we can all understand that here. We're all adults, right? We have good developed tastes. And you deserve to be bullied if you liked the more recent one better. But it's not my fault that art is objective, right? This is why they won't let me teach at PNC. I was like, can I get a room in PNC? And they're like, no. I was like, oh, that's interesting. Right. So a student, a very nice student, someone that didn't know me that well, said, oh, you should get a letterbox. And like probably 8 students in a 30-person class immediately said, no, Calvin has enough social media accounts already. And I was like, what does that mean? How many social media accounts do you think I have? So anyways, this tweet was posted on Twitter, and then it was cross-posted to Blue Sky by philosophers based in the UK. So that's who this is from. I am a weapons-grade finitist. I don't believe in numbers larger than 2. Does anyone in here believe in numbers larger than 2? Yeah, right, they could exist, right? Approximately, yeah. There's numbers approximately as large as 2, yeah. Anyways, this person is actually correct, right? Because, in fact, all of the things that appear to be larger numbers are actually vectors of numbers that are either 0 or 1. So, I'm sorry, I don't make the rules. There are only finite numbers. And I will leave as an exercise to the student to construct the real numbers using only such vectors. We're going to start by reintroducing standard int, because standard int is our frame of reference for numbers of fixed size. Some of you have seen basically any modern programming language. It is unheard of, even Python, if they're using NumPy or something, forces you to specify how many bits you're using. It was a colossal mistake that the early C language did not specify how many bits an integer was, right? We have paid for this dearly. It is the reason the internet doesn't work, as I mentioned, right? Nothing works because ints are the wrong size. It was important to me to teach in C89 this term so that you would understand and come to believe that you do not need all of the modern features of modern languages to get things to work. And also that you would see some of them really should have been there the whole time, right? I have not been persuaded that we need object-oriented pair programming. Do not tell Professor Lucas Cordova. I am relatively persuaded we do in fact need higher order functions because I get halfway through writing one in a different language in C and then realize that that's not C that I'm writing, right? I've been extremely persuaded that you should always have a number after int that specifies how big it is. And so we're going to deal with that today. I could, in fact, have forced you to implement this entire class using cints, but even that would not work because the compilers they were using in 1989 and the hardware they were using in 1989 was providing different integer behavior anyways, right? What I really should do is require you to use int16ts and implement everything in that. But that seemed a little bit mean even for me. So we're going to introduce a little bit of mathematical notation, and some of you will know some of this stuff and some of you won't. So if you're bored, tell me to go faster, and if you're having a good time, tell me to slow down or whatever. So the integers are denoted with the mathematical symbol z. That's script z. If I were to write that in Quarto Markdown, it would be $, mathbb, no spaces, open curly brace, capital Z, end curly brace, and $, or mathbbz. Which I think, did you write mathbbrn? No, I wrote that. When we were joking about analysis in Rn, I always refer to that as mathbbr for the real numbers, because that's a way to denote that it is the script R, not the R project for statistical computation that we all know and love. Do you all love caret? Caret? I really felt that I was using R this week, and that was the first time I really felt it. I was like, whoa, I am passing a lot of tune grid hyperparameters. Anyways, I am not a huge fan of calling it Z, which I think has to do with either German or Deutsch, depending on, I don't even know if you're supposed to refer to other languages in their own language or the anglicization of the name of the language, right? There is an algorithm, the extended Euclidean algorithm, that we're doing in 2 weeks, that uses integers to great effect in cryptography. And it just kind of feels like cheating the whole time. Like, I think I shouldn't be allowed to do that. I should have to use natural numbers because inside the computer, right, I only have vectors of these finite numbers that are either 0 or 1, right? And they can't be negative. I don't have a way to store negativity. So really, I think in general, we should be working with the natural numbers. And I mentioned I was talking to mathematicians today. I try and check my work on all this stuff because I'm not a true mathematician, right? And we did agree that 0 is within the natural numbers. So the natural numbers are the numbers we use to count things, and so we count 1, 2, 3, 4, 5 of things. And well, can we count 0 of things? Yes, of course. 0 is the number of elements in the empty set. I don't make the rules. Empty sets are all around us, right? The empty set contains the number of how many bothers I give, right? Yeah. So, okay. This is a way to write both the natural numbers and the integers in Python. I don't know that you can do this in JavaScript. Any JavaScripters? There's not integers in JavaScript, right? There's a big int type. Does this look like something you can do in JavaScript? Okay. I don't know if I don't know JavaScript or you don't know JavaScript. We'll never find out, right? Here, we can probably just like open console log real quick. How do I do this? How's JavaScript? How do I get to JavaScript? It's in here somewhere.
You should be able to do
Inspect?
Yeah.
Control Shift C? Ah! Or sorry, I meant to do that. So if I were to write, I don't even know how to write loops in JavaScript. Wait, is that? Okay, if I were to do let I equals 0, can I just do a semicolon for a line break?
Yes.
Do I have to put a body of the while Can I just do this?
You do. While at plus plus, I don't know. Well, are you trying to create infinite?
Yeah, this is the natural numbers,
Oh,
right?
okay.
So I can express the natural numbers in JavaScript. I forgot. I was going to say ECMAScript. I was like, no one calls it that. That's what a nerd would say. Anyway, so we can, in fact, express the natural numbers in JavaScript, but versus Python, which has some of the delayed evaluation functional niceties, which JavaScript may have, and I just don't know where they are. I don't know a way to store this thing inside an object, right? I can't delay the evaluation of this. This is just a way of expressing the notion of the natural numbers. Versus, I opened command prompt instead of terminal. What? I type Python instead of Python 3 because I'm still on Windows. From itertools, import count.
There are generators in JavaScript. I don't think anybody uses them for anything.
I don't know that people use generators in Python.
The range is a generator.
That's true.
People can write their own generators.
Are ranges, do they have delayed evaluation?
I think they do. I think a range is a range object. It's not like a raw array unless you turn it into one.
That won't change it, right? I'd have to do something else. Can we say I don't know that this is going to work. Is this consistent with maybe what you were thinking, Ari?
No.
Okay. Because that doesn't have delayed evaluation, right?
I think
It builds the range instantly, but it doesn't pull everything out of
You
it.
can't change the end of the range afterwards.
Can't change the end of the range afterwards. Okay. I have to check it. Yeah, okay. Okay, so we have the natural numbers, which are count. We start from 0 because it is a computer science class. Here are the other classes it could be to start from different numbers. A math class would commonly start from 1. And depending on the language, the data science class may start from 1, right? There's one exception to this. On the day that you teach heaps and data structures, the natural numbers start at 1. So here's the natural numbers, and the way we interface with these in Python is we use the next command, which pulls things out of n, and it keeps going forever. There's an infinite number of these. An astute learner will realize that this means that in a single line you can write the Python expression that contains all of the prime numbers. And every once in a while I remember that, and then I lose hours of sleep until I finish the expression and get it going as fast as I want it to go, right? But in fact, there is a algorithmic technique called the sieve of Aristophanes, or I don't know that that's how you say it, but you can write that in a Python one-liner, and it just, it's a great joy. It's a great joy to have that, and it can also be expressed in Haskell in a single line. So these are the natural numbers. I have been more intelligent than I am today, so I'm not going to attempt to construct the integers without help, but I am going to show them to you. So given the natural numbers, and I'm going to reconstruct them now, I'm going to say n equals count 0. We can also construct the integers, and the integers aren't too bad. So the integers contain all of the positive numbers that the naturals contain and all of the negative numbers. And so the first mistake that everyone always makes is, oh, I'll just write down all of the positive numbers and then I'll start writing down the negative numbers, but the problem is there's an infinite number of positive numbers, right? And this is the same mistake we make where we can't write down all of the even numbers and then start writing down the odd numbers. You're actually just going to only write down the even numbers. So we have to do a little thing where we go back and forth. This is teasing the notion of a diagonalization. And I'm going to plant these seeds in case you ever come across a diagonalization later in your life. And depending on how things go, there was a planned bonus lecture on diagonalizations that may or may not happen. It might be displaced by another planned lecture on generating RSA keys. But I'm going to take the natural numbers and I'm going to use that to make the integers. Now, to my knowledge, there is not a Python iterator that gives you the integers. And why would there not be? What value would you start at? Well, the integers start at negative infinity. which means that the first infinite values are negative infinity. So that's the same thing as returning negative infinity, right? The common way to do this is you start at 0, and then you do positive 1 and negative 1, and positive 2 and negative 2, and so on. But actually, you can do this in any order. You can do any finite number of positive or negative values and then toggle to the other one. It makes no difference. But you do have to have a finite number, and this is the importance of finitism that is coming back. So I'm going to do this by saying, well, I'm going to make a generator called z. In Python, generators are enclosed in these brackets, and this is the difference in between delayed evaluation, and if I put the boxy brackets there, it will calculate the entire list immediately. So I cannot say, for example, I think this will cause some disaster to happen. Yeah, so that's an infinite loop, because that's trying to create the list that contains infinite elements. We did it, we got out. Okay. From iter tools import count. That was what I did. But this is perfectly legal to my knowledge, which is that I can say C for C in count. That's totally fine. Completely allowed to do that, because it's not going to start evaluating that thing until I apply next to it or write a loop over it. I can say, you can put it in a for loop or whatever. You know how ranges work, right? Same thing. So we write the integers, and the way I'm going to write the integers is I'm going to take a function that goes from the natural numbers and it returns some integer. The natural numbers are closed under some operations. If I add any two natural numbers together, I get a natural number back. If I multiply any two natural numbers together, I get a natural number back. These are the positive numbers. But I cannot subtract natural numbers from other natural numbers and get them back at high probability, because 3 minus 7 is simply not a positive number. And we don't talk about division. So do not trick me into talking about division. I will not speak of division. It's a simple enough matter to say, well, we need some way to make these things negative, and I'm going to use a little trick called subtraction. I'm going to subtract them from 0. So I'm just going to write a negative sign there. But I'm not going to do this for every natural number. So I'm going to say we have C for C in count, but I'm going to do some operations on C. The first thing I noticed is that, when I use the counting numbers, I go 0, 1, 2, 3, 4. When I'm doing the integers, there are 2 1s, 2 2s, 2 3s, and 2 4s. So that suggests to me that my numbers can get bigger at exactly half the speed. So I'm going to divide that by 2, and I'm going to use integer division, because I'm trying to get to the integers, right? This is exactly what it's for. This is why it was invented, right? And then I'm going to note that I want exactly half of these things to be negative, and that's no problem at all for me, because I know that exactly half of the natural numbers are even. So I'm just going to check to see if this thing is even, and if it is, I'm going to make it negative. So how do I do that? Well, I can check to see if it is even with the modulo operation. And then I can use a ternary, is it ternary or trinary operation? Ternary, because you take your turn, okay? And I think this is not how I did it on this side of the screen, which is okay. I made a terrible mistake where I put 2 zeros in there. Just kidding, actually, the second one of those is -0. It's not printed out correctly, and it is up to our best scientists to determine whether -0 is a different number than +0 or not. I wouldn't want to weigh in on that. I've heard it makes sense to think of them as different numbers, especially in the natural sciences, where you use -0 to denote you have a value that was rounded down to 0 from the negative side. So in fact, preserving the sign there does contain information. Now, because I only believe in a finite number of numbers, I've never seen -0 before, but I know that the scientists might want it, and I think of them fondly. I hear some of them made the internet, but I can't actually confirm that. So anyways, here's the natural numbers, and this is how I did it on this side of the screen. How did I do it on that side of the screen? I used a lambda, but it's the same lambda, right? It looks the same. Yes?
What does it mean for a number to be natural?
A number is natural if it is, so okay, there's the philosophical answer to that, and then there's the practical answer. So we'll do the philosophical answer first, because it's perhaps more interesting. If it can be, if it is one of the counting numbers, if you can count things with that number. And so the classic example of things that you count is sets. So I can take the null set, and often this is used to denote 0, or I can put the null set inside a null set. Or I can put the null set inside an otherwise empty set, right? And so that is the set that contains one element. Well, I can't put two null sets inside of another set. Let's draw this out. So 0, ooh, I can't type 0 equals. This is not the empty set in Python, this is the empty dictionary, so I have to say this. So that contains 0 elements. By convention, we denote 1 as the set that contains the empty set. Ooh, does that not work? Can you not put sets inside sets? Oh, wait. I thought this would work. Do I have to use...
I think that when you create a set, you can't just put the first element, you have to enclose it in something. So try set and then, yeah.
Is this okay? It's unhashable. I can't put sets in Python.
Oh.
We're just going to use lists and we're going to say they're sets. That's what Python would want us to do. Not to worry, I have a plan. So we take 0, it's equal to the empty set. We're going to take 1, and that's going to be equal to the set that contains the empty set. Now, we're using lists, so I could in fact put 2 empty lists in there. This is Python legal. But it is not set theoretic legal, right? You cannot have duplicates. So how do we represent this? Well, 2 is the set that contains 0 and 1. Let's see, so it contains 0 and it contains 1. And the natural numbers are constructed in the following ways from the empty set and set inclusion, right? So they are constructed, we can think of them as a language. In practice, they are the unsigned integers.
This is what you're referring to by vectors, where there's only 0 and only 1, and everything else is constructed from 0.
Well, I would argue that this is constructed from only 0. And you have some number of zeros in a different arrangement, right? When I was arguing for constructing from 0 and 1, that is bit vectors. So that's just binary representation.
There's a such thing as a frozen set in Python, an immutable set that you can probably put into a set.
Why would you curse me with this knowledge?
So you don't use lists.
But we love using lists. The greatest programming language is named after Lisp processing. It's true, look it up. It came out in 1960. It's called Lisp. Any Lisp programmers in here? Good, let's keep it that way. Okay.
What was the practical answer?
The unsigned integers. Yeah. Or the positive numbers, right? But the thing is, I don't think there's like a good way to refer to integers, right? So many of the terms we use to refer to numbers are like in the 1,000 most common words used in English, right? Integer is not one of those. Usually people say whole numbers or round numbers. That like sketches me out a little bit. To me, round numbers feel like numbers that were rounded, and the whole numbers feels like the subset of the fractions that aren't fractions, right? So like 2 halves feels like a whole number to me, but does not feel like an integer, right? That thing's a fraction, right? That's a division that hasn't been evaluated yet. So I do lean strongly on integer for that reason. To me, it seems like my intuition is correct because all of the computer science languages converged on using the term int. And ints are in fact different than the integers, but they model the integers, right? The integers modulus and that. I'm providing an academic citation on the notion that it is strange to consider 0 one of the natural numbers. You remember SHA 256 last week? I had to index one thing to 1 and one thing to 0, and it was chaos. Here's the citation. Yes.
I'm so sorry that you didn't find natural numbers for you.
Yes, is the unsigned integers.
One more time, a different way.
It is the positive, whole, or round numbers. It is the numbers that can represent how many particles are in the universe. Okay, well, it's strange to say physiological phenomena because we can have negative speeds. It's the amount of stuff there is. How many fingers you have, things like that, right? And you have to be careful when you start doing speeds because it's like, I can go 37.5 miles per hour, right? But you cannot have 37.5 cars. So that's sort of the intuitive reason that they're different. The linguists have looked at this much more seriously, and I think there's naturals and also ordinals, but I don't actually know anything about that, so I'm not going to say anything further and confuse us. Anyways, 0 is in the natural numbers, which means we can count 0 things. And there are many things that I have 0 of, and one of them is a working laptop. So that's a great example. We can just... so I talked to WITS, and they found me a laptop with an NVIDIA chip in it. So it's possible we'll be doing some CUDA C++ by the end of the semester. We'll see. There's this little problem that I don't know CUDA C++, but I can fix that. I can't fix the laptop problem. Maybe this summer we'll learn CUDA C++ in Rust, which is impossible. I checked. You can't write good CUDA code in Rust. It's against the law. They are diametrically opposed. This is probably the slide I should have gone to answer that question. N is the unsigned integers. But it is not the unsigned, it is not uint 8t. It is uint infinity t. It is infinite precision. The same semester, I was taking my first systems class from the person that invented the internet. I just mentioned Rust. The CEO of the Rust Foundation is named like Lars Bergstrom or something, and for some reason covered exactly 2 classes in my undergraduate functional programming class in undergrad, because I think like owed someone a favor or something. Anyways, at the time this person was a mere grad student, and you are all accustomed to how mere grad students are, right? And so, is that the right name? I don't remember this person's name. Anyways, European in the US for grad school, and now works for Google, running their Android team. So there's 2 types of problems in computer science. And there's problems that the hot new startup coming out of Silicon Valley can solve, and there's the problems that they can't. And so in this sort of series of lectures, the thing we're going to build up to the problem is that it's really hard to divide 4,096-bit integers by other 4,096-bit integers. But this person, whose name was maybe Lars, would always say, that's not a problem because I've got a hot new startup coming out of Silicon Valley that's got cracked programmers, and they're going to write the best division code you've ever seen. It's going to be bug-free, it's going to be fast, it's going to use all of the optimizations, it's going to be great. So you don't have to worry about it. If a computer can do it, a hot new startup out of Silicon Valley will solve that problem. I was like, cool, right? So we don't have to worry about anything. It's like, here's something I don't have a hot new startup coming out of Silicon Valley going to do. No one is working on having computers with infinite memory. I was like, oh, that's true. So we're not allowed to assume that we have infinite memory, because that's not a problem that we'll ever solve with computers. We can assume that someday things will be much faster, right? But we will never be able to have infinite memory, which means we can never put pi in a computer. We can put in an expression that could evaluate pi, but we cannot evaluate it. And in fact, just now I showed you something that was infinite in a computer, but we can't actually study it. We can't take the entire thing. I think it's good to have an intuition about this, because Python does like to pretend it can be arbitrarily large. They don't tell you how many bits they're using. And in fact, I think just last week we saw that they definitely lie about how many bits they're giving you as well, right? So we don't trust Python because Python is a snake and you can't trust snakes. There's an entire book about it. That one's, yeah, some people paying attention. Okay. So the Python integers do have an upper limit. And it is true that when my hot new startup out of Silicon Valley gives me my new NVIDIA accelerated laptop, those numbers will get bigger, but they will still be finite, right? But I can use logical notation and I can say, there does not exist some counting number that is not part of Python itertools. There's no number I can type into my computer that is not part of count, right? So any finite number is certainly storable in a computer. I just keep making bigger computers until I can store that very large finite number. And so I thought I would pick a relatively small finite number, Googleplex, which is 10 to the 10 to the 10th. So that's 1 followed by 100 zeros, and then you have 10 raised to itself that many times, which is some big number. I don't know, it's not that big, right? I can write it down. See, it only took a few characters to write it down. And so I'm going to try and see if I can write that number in Python and, do some performance characterization and see how fast things are. So I'm going to do this with command line calculations, and at this point in time, I am going to boot WSL because I don't really want to be working in Windows if I don't have to be. The command line utilities are just, ugh. Yeah. Okay. So I'm in my mounted drive. Let's move to home. Let's clear this. And just like that, there's no evidence I'm working in Windows as long as you don't look at this little thing right here. Right? Okay. So, within the Linux command line, it is common for me to use Python as follows with an immediate. I don't know what C stands for. Does anyone know what the C there stands for? Google it. Yeah. But I can print things directly at the command line this way. This can be a nice way to use Python from time to time. It stands for command. Cool. So I can do calculations and I can look at the results. I can also do calculations without looking at the results. And I know what many of you are thinking. You're thinking, but what if I need to use 2 lines? Not to worry. A lot of people don't know this, but Python is actually just a C front end. So you can use semicolons to separate lines, which means you can write just about anything you want in single line. Did any of you do Advent of Code this year? I did the entire thing at command line in this format. So all of my solutions were single line command lines, and I submitted them as bash solutions because you can run this in bash if you have Python added to your path, right? Everyone hated this. The bash people hated it. The Python people hated it. Professor Lucas Cordova hated it. He said, how do you step through that with a debugger? I said, a what? And that's why I'm not a software engineer, right? A lot of people don't know this trick where if you just write code without bugs, you don't have to use a debugger. So I enjoyed doing that. We're going to go ahead and do some characterizations with count. Python 3, C, from iter tools, import count. Sorry, it goes on to 2 lines. I'm making the claim that this is more reasonable to have split lines and show the slides in the command at the same time. Your mileage may vary. Just toss a semicolon in there. It's our favorite punctuation mark. In fact, I tried very hard to submit my entire doctoral thesis only using semicolons, and that was really unpopular with everyone except me. But we can say, hey, is 0 in count? And so it is. True. And all of the mathematicians are gnashing their teeth, and one of the mathematicians is like, well, actually, I do discrete math all the time, and we use 0 in the natural numbers, and then they fight. It's funny, right? What are we going to do? We should do this in a Podman container. What am I doing?
Sorry, just taking a step back for a second. What are we showing here? That numbers aren't infinitely large, or that's like the goal?
Yes, we're going to demonstrate the high costs of pretending numbers are large. And then we're going to show that C is faster than Python, and we'll proceed from there. The pitch on doing things this way is a lot of times you can tell students, hey, isn't 2 to the 128th bigger than 2 to the 32? And they say, yeah, sure. And then you look up like how many more years it takes to count to 2 to the 112. You've got to do it intuitively. So we're going to do a little bit of performance characterization and do a little bit of complexity theory. So look forward to that. Does this thing have Python 3 in it? No problem. Wait, really? You don't have to work in containers, but you always should, right? And why should I work in containers? Well, I want to have a consistent framework for everything. I want to have the exact same operating system. I want to have the exact same version of Python. I want all of my experiments to be reproducible, especially because I'm going to be taking timing data, which I am in fact going to be doing in a moment. It makes a lot more sense to make sure I'm running this in a container so we all have the same considerations, right? You could in fact use Alpine or Debian. That's totally fine. But I think I should do this. And I thought my packages were up to date, but I guess they're not. There you go. Does anyone know the latest version of Python? Are we still on 3.12.5? I think we're about to find out. Is the internet slow in here? That feels like slow internet, but not bad. Really? That does seem like a lot of Python. Cool. I would not have done this if I'd known the internet was slow, but that's okay. I should have timed this. Because, like, it isn't helpful to know how, or like, we know intuitively it feels slow. But what I should do is I should time this here, and then I should immediately go home, plug into Ethernet, and time that. Really? I'm 2?
Yeah, you're not Pacific.
I'm in Anchorage. I'm in... Wait, what is happening? Ari, what do I type?
I don't know at this point.
Anchorage. And so what mistake did I make? You're supposed to do this one. You're supposed to have the Y there, right? Okay, so we got Python 3. And, ooh, I was going to switch to SH, and then I won't be able to use up arrow. Okay, so let's not do that. Let's do Python 3 C from itertools. Import count. Print 0 in count. Okay, true. Why do I do this at command line? Well, there are in fact built-in ways to measure how fast Python code works. And I'm going to assume that if you're a Python programmer, you already know those things, and if you're not a Python programmer, you don't care about those things. I am going to make the assumption that I think ought to be correct, that you should be able to time things that run at the command line. And you'll never guess what command you use to do that. It's in fact time. So we can just go ahead and put time in front of all of this and see how long it takes to count to 0. Real time, and then this is the time in user space, which is code that ION's running, and then this is time in operating system space. What's the thing that's probably going on in the operating system? Well, I'm guessing Python is making a request to the operating system to find itertools, and certainly things are running through the command line. So I'm a super user, so I'm very privileged, so some of my requests will go through the operating system, probably minimally including print, right? Printing things out is going to have to be an elevated privilege. So I'm spending some amount of time, working with memory that's relatively protected, and then I'm spending some amount of time just running Python naively, right? And in fact, the same thing would happen if I grabbed GCC and I did some of those operations. Let's check some other numbers to see if they're also in the natural numbers. And I suspect I can put, for example, 10 in here. And that's about the same speed. It's interesting that we have a different user versus system distribution. It's neither here nor there. And in fact, I can go up to 100. And in fact, I can go up to pretty large numbers before I see any appreciable speed. My intuitive sense for what's going on here is a lot of the time that it takes to check to see if a number is a natural number. It's getting Python up and running, finding itertools, importing count, building count, and then calling print, right? So that's dominating the time cost. It is relatively cheap to look at a large number of numbers and see if they're equal to 100. But this isn't going to work forever because I can put any number into Python I want to, which means my numbers can keep getting larger. And in fact, we already started slowing down depending on the real versus user performance. Slowing down a little bit, and what is that? That's 5 zeros. So I think at this rate, I probably can add a Googleplex zeros, right? There's nothing wrong. But I suddenly did hit a performance snag here at, let's make this a little bit easier on ourselves. Is this 10 to the 6th? So it is. Right. So already only at 10 to the 6th, which you can probably count to in a short amount of time, right? Wait, that's only like 1 million or something? Very small number. Is 10 to the 6th a million?
Yes.
That's 1,000, right? So, I don't know. That's not a very big number, right? If you had 1,000 by 1,000 of something. Right, pixels. Okay, so I have a 1920 by 1080 monitor, so I'm looking at 2 million pixels right now, and that's only 1 million. Relatively small number. But in fact, my performance is much worse. And now I'm going to look for a number that's 10 times bigger. And I should speculate that now that things are slowing down, probably a large amount of this time cost is coming from how long it takes to look up the number. So I'm going to make a guess, right? I'm going to speculate that because before this, it took 0.02 seconds to do all of the Python stuff, and I went from 10 to the 5th to 10 to the 6th, I added 0.03 seconds. I'm guessing I can do roughly 10 to the 6th checks in 0.03 seconds, so probably if I'm doing 10 to the 7th checks, that's going to take 0.03 times 10 seconds, and then there is also a 0.02 time startup, so I think I should get back 0.32 when this runs. We'll see. That's pretty good. And then I suspect that this means that I'm going to get roughly 3 seconds if I put 10 to the 8th in there. Faster, good. So what this means is that, well, it would be really nice, in fact, to pretend that I do have the hot new startup out of Silicon Valley that can handle the natural numbers. In fact, I should not regard my computers as being able to contain natural numbers. It takes a very long amount of time to work with very, very small numbers. What is the log base 2 of 10 to the 8th? That is 100 million. What is log base 2 of 1,000? It's 100, or it's 10, right? 2 to the 10th is 1,024. So if I have 100 million of something, I have 100 times 1,000 times 1,000. So I have 100 times 2 to the 10th times 2 to the 10th. 100 is in between 64 and 128, which means it is either 2 to the 7th or 2 to the 8th. So this is roughly going to be 2 to the 26th. I don't remember how to calculate logs, so I'm just going to check the bit line. Ah, it's 2 to 27th. I'm a fool. Never try and do math in front of a class. 27, that number is small enough to fit in Ian Foster's internet, right? This is a very small number. This is a 1989 size number, and it already takes Python single-digit seconds to deal with a number this small, right? From here, we can calculate how long it takes to deal with the Googleplex, right? Okay, so if we take 3 seconds per 10 to the 8th, let's do a Google first. Let's see, Google is 10 to the 100th, right? So we raise that to the 92nd power. So we have a 3 followed by 92 zeros number of seconds. That's a long time. I'm not going to figure out how long that is.
You wrote Googleplex before as 10 to the 10 to the 100, right?
Mm-hmm.
Can't you just do 10 to the 10th here and then take that and go to the 100th to figure it out?
Then what would happen? So if I do 10 like this, right? Is that what it is? Like that? How long? Let's see. And I think that's just 200 zeros, right? Len, stir. Oh, 1,000. 10 to the 10th is a 1 followed by 10 zeros. If I raise that to the 100th power, I take that 10 zeros 100 times. This is a 1 followed by 100 zeros. If I raise 10 to this power, I add a 0 that many times. So it would have this many zeros on it. And this number is more than 1001. Does that make sense? It's the difference between and if we move the parens around, I don't know that I might be able to do this. This is a big number. I probably can't do it. This is dramatically larger.
Yeah, that makes sense. I was saying for the timing, you had the time at 10 to the t.
Yes.
I was saying we took the time for 10 to the 10. It would just be easier to take that to the 100 rather than starting with t.
We wouldn't raise that to the power of 100. We would multiply it by 10 to the power of 100 because it's that many times bigger. It's a ratio.
Gotcha.
Right. Yeah, it's a ratio of different speeds to each other. I thought this might return eventually. Am I off?
Did you just calculate that right above there?
No, these are different numbers.
That's the one with the 1,000 zeros.
Yeah, what was that?
Oh,
That's 10 to the 10th to the 1000th.
oh, we just did it. Oh, like 10 to
Yeah, so this is 10 to the... This is a 10 followed by 10 zeros, so it's printing, or it's trying to print 100 million zeros. Right. It seems fine, right? It's not hot to the touch. Oh, we're actually going to stop this right now. Okay. Sorry, Python. I forgot you're not optimized.
But the printing is iterative, and it's like it has to do the whole thing, then print. It's not just going to go 0 and keep going.
Yeah, the expensive operation should not be the math, which I bet it can do the math quickly. Actually, we can check. Nope. Okay. There are things you can calculate in Python that you can't print because printing is thousands of times slower than calculating. So you lose printing well before. And this is why things like scientific notation exist. Right? It's like, oh, I can work with numbers that are quite large. But of course, once you start using scientific notation, you're like, can't you throw out the bottom like 10 million digits and just not think about them? And yeah, usually, right? Like if you just keep the top 10 million digits, you're not losing a lot of information. So, here's some calculations I took. I did these on my home desktop, which you see is basically twice as fast. It's connected to Ethernet, and it doesn't melt. Well, I mean, it will someday. Right? I got Bloodborne for PC running on it, so it's really been working very hard lately. But I would encourage you to think about how you can write this and test it yourself, and how you can also do this to any C code you write. It is not, in fact, that hard to do command line things to C, and I showed you this with macros, where I showed you with macros how you can rip some lines off of a file and throw it into Jesus. So there are, in fact, ways to do this. Here was the data I took at home, and if I were as smart as I wish I was, I would have just done all of these calculations live in front of you. But I calculated that it would take 316 novum vigintillion years to check to see if Googleplex is one of the natural numbers, which is odd because I can ask a toddler this and they will respond instantly. Right, so I don't know. I'm not really too worried about the AIs yet. Like if you can't even check to see if things are natural numbers, is your underlying hardware that smart? And of course an LLM will say the correct answer to this, but it can't actually calculate it, so it's not doing anything I can't do anyways. It only knows that this thing's a natural number because I'm quite likely to say it's a natural number, right? I love C. I love the C programming language. It's one of my best friends. I've heard that the secret to happy life is having strong adult friendships, so I've picked someone that'll never leave me. The GNU C compiler, right? One of my closest and steadfast friends. A member of my bridal, no, but what's the bridal party for the whole wedding? A member of the wedding party just got a 10-year track position at UCSD in the statistics department, right? Thank you, Ari.
In the statistics department?
Yes, and we have not spoken since the wedding, but that's one of my best friends, right?
About mathematics at UCSD is that it's part of the School of Physical Sciences along with chemistry, I'm pretty sure.
That's cool. What does that mean?
I mean, what else would it be under?
Yeah, fair enough, right. As we can see, computer science is a physical science because the computers are made out of physical materials, right? So it would make sense to use physics for this. This script is great. It's not very fast. You may realize that this thing is probably going to run 2 to the 32nd times. And so what, of course, we do when that's happening, is this thing not going to have vim in it? You know what? We're just going to exit this podman container because I think I have everything locally. Okay. Vim max.c. Oh my gosh, it's already in there. One little change that I was going to make manually. That says 32. This says 16. How many times faster should it be to find the largest 16-bit number than it is to find the largest 32-bit number? Should be 2 to the 16 times faster, which is 1,000 times 2 to the 6th, which is 64. So this will run 64,000 times faster than the thing on the left-hand side of the screen. If I put a 64 in there, how much slower would that be? That would be 2 to the 48 times slower, which is about a quadrillion. So these numbers get very big very fast, I think. Anyways, let's go ahead and run this. What else is in here? I have something called Hatter. What's in there? Oh, it's the height adder. I should have deleted all of these things, probably. Okay, let's do gcc max.c. That's pretty slow. Wait, what am I doing? Not to worry, I have a plan. So it appears that I've made an error in my code, because I think I can do 256 things very fast. Oh, did you see the error?
I did not see the error.
Well, n plus 1 is greater than n plus plus. I'm actually going to claim it's unlikely you saw the error here, because this error is related to something very, very sneaky that C does.
When you do math, it doesn't things as a
Yep. This is an 8-bit integer, n. 1 is going to default to be a 32-bit signed integer. And when I add a 32-bit signed integer to an 8-bit integer, C knows what I want. It knows that I secretly wanted a 32-bit integer the entire time. And if I add 1 to any 8-bit integer and store the result in a 32-bit integer, it will always be larger, because the 32-bit integers do not overflow. This is great news. C is not losing information. It's doing exactly what you told it to do, as long as you assume that every number you type into C is a 32-bit unsigned integer.
Could you fix it if you did it while n plus plus is greater than n and remove the body of the while loop?
Probably. Am I in insert mode? No. Okay. How much do you want to bet on this one, Ari?
I will bet the amount of cash I have on you, which is exactly $0.
Which is a natural number of dollars. See, it's a counting number. You got it, right? Okay.
I'm not counting how many totally how much cash I have. The amount of cash I have doesn't have to be an actual number. Does it not work? Wait, did it work?
Here, I'll show you. We check the value of n. We increase the value of n.
Well, n is smaller than n plus plus.
Can you also cast one as wherever you want it to be?
Yes, 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 yes. Let's fix this first, and then we'll do that. Wait, why am I doing it this way? Here, I'm going to make a single command. Okay. I didn't? Really? Is that what we're going for?
No, you would want to move n before, so you want while n is small, or while n is bigger than n plus plus. Because that way we will get the value of n before we add to it. Yes.
This is what we think we want?
I think so. Let's find out.
Goodness me. Okay. I'm pretty skeptical of that one.
Greater than or equal to.
You like greater than or equal? Sure, we'll try it. Is this how you write code?
Yeah, pretty much.
Okay. So we need to increase the size of n, and then compare it to see if it got larger. Is this not what we want?
This might not get anywhere because when you run it the first time. Oh no. Yeah, that should work.
Yeah. Okay.
0.
0? Okay, that's not great. Ah. Oh, not an insert mode. Okay. I think my preferred way to do this.
You could just cast one as a.
Yeah, let's try the one cast. What did this look like originally? We said n plus 1 greater than n. Okay, and then we put this inside parens. Whoa, what am I typing? Okay.
Cast the one as u and a.
So with what you were just doing, if n has a u and a, and you subtract 1 from it, is that unhelpful? If it has 0, can you
Yeah.
subtract 1 and it becomes assignment? Or
It is treated as a signed int. It doesn't become anything unless you store it in a variable with a type. But you could print it out as an unsigned int, and then the value would be thrown away. I think it doesn't make sense to think of intermediate values as having types so much as plus will coerce types for intermediate values. I'm going to stop talking. That seems like that got weird. Here, let's see what happens here. Here, I have a plan. We're going to talk about something that we might understand. Bad guess. Okay. So,
Oh, you didn't actually increment that.
no problem. Oh. Wait, was that why the other ones weren't working?
No, the other ones were working. The other ones we were incrementing. Okay.
Okay, that's not great. Let's see.
You have to increment the body.
Wait, we should do this, right?
So I just want to put n plus plus in the body rather than.
Because when you add 1 to n on the left side, you're also adding 1 to n on the right side, and it would be equal.
It shouldn't add the plus until it's done calculating, I don't think. I think we're really bad at writing C. And the reason I think we're really bad at writing C, I do know what's going on this time. That plus is still coercing. It doesn't care. We have to cast, I think, the return value. So wait, maybe we can do this, right? What if instead of there being a cast here, let's see if this one works. I haven't tried this one before, but I think it'll work. I'm staking my claim. There's an off chance that this will be successful. Okay?
How much are you going to bet?
0. I'm willing to bet the size of the empty set. But I should have bet more. I should have bet 255, which is also equal to -1. I'm going to show you one other thing. This is a common question. I didn't realize this. I had a student do, let's see, this. D print code. Wait, am I not in insert mode? What am I doing? Okay. One of the things I didn't realize, so I never taught a class in Vim before. I started using it for hacking. While I'm teaching, some of you may have noticed that my train of thought does like this, like, right? Turns out you can't do that while you're using Vim because you have to know what Vim mode you're in. And I have no idea what Vim mode I'm in at any time, right? So I think the solution is that I should teach in Vim even more. I've decided that the problem is that I'm weak. Okay. %d, decimal, right? Decimal is often used for signed decimal values. And that's going to work for 255, right? Because it's assuming it is signed 32-bit int. Why was this a problem? Right. Let's see. Insert. Right. Okay. Delete. Okay. I'm just going to tell you the anecdote because I don't think it makes sense to demonstrate it. A student was using %d to print unsigned ints and said, my ints are signed. I said, no. You're trying to print them with signed bits. So you can print out a signed or unsigned value as either signed or unsigned. The print code has no correspondence to the internal type. The usefulness of using unsigned versus signed values is only in some specific arithmetic operations which treat them separately. Specifically, the rotate works differently on signed and unsigned values. So just be aware of that. There's all of this type coercion going on. Type coercion goes on with format codes, and it goes on with all of the arithmetic operators. Look out for it. You might run into this on BigDiv. On all of the big operations I was using, I was constantly running into problems where I was took a pile of bits and I split it into 32-bit chunks and I multiplied them together, and I wanted those to be in 64-bit chunks because if I multiply two 32-bit numbers by each other, they're not going to be more than 64 bits in size. Easy, no problem, right? You cannot assume any of those operations are going to keep the same size, right? You have to check every single one of them. So you have to multiply 2 to the 20th by 2 to the 20th and see what happens, and make sure you're not accidentally cutting off tons of bits. So just look out for that. Okay. Oh, we should time things. Okay. Or we'll do a 16. Yeah, I did capital X, right? Okay. Ooh, what did I do wrong? I need to do N here. Okay, that seems fast. I'm going to time this and decide if I'm willing to do 32-bit. I'm cheating. You should all notice I'm cheating. I'm going to measure the performance of something in C, and I'm not going to count compile time. Just be aware of that. If you're comparing this one-to-one with Python, it is a little bit sketchy to not time GCC as well. When I do my performance demo at the end of my CS 151 class to ask students to take this class, I cheat. And then I show them that it's still faster even if you include compile time, and they hate that, right? They're like, oh, I was sure I was going to get to use Python next semester, but they weren't. Oh yeah, we can do like many times that much speed. I'm just going to write int. I think that's okay, right? We'll see how big ints are. Where's delete? Oh, does that need to be in parens? I don't know if it needs to be in parens. Do we think this code will work? Don't see anything obviously silly before I try and run it. Because it's going to take a moment, so we want to fix it the first time. Okay, so it took 5.19 seconds on my desktop, which seemed to be about 2.5 times faster. So we're going to need about 15 seconds. I didn't start counting when I started talking, but we probably have a few seconds left.
Is default 32-bit or 64?
I expect it to be assigned 32-bit, but if it is in fact a 64-bit, we're in big trouble, right? Like real big trouble. I wonder if I look away and then I look at it quickly. Okay, actually. Yeah, that probably shouldn't have happened. Okay. Only one way to find out. I want this to go twice as fast, so I'm taking the sign bit back. That will speed up my time twice as much. Am I typing? No. Maybe we can give this 10 seconds. The thing is, it should be 2 to the 16 times this. And 2 to the 16 is not that big. That is a 500th of a second. Oh no, 2 to the 16 is much bigger than 500. It's 2 to the 8th times bigger than 500. 2 to the 8th is a lot. Well, we tried. It was very fast for 2 to the 16, right? Yeah, that's too slow. Where I did have my high-performance computer and was able to take these characterizations, I found that I could go to 2 to the 32nd in 5.19 seconds on C and 1 minute and 9 seconds on Python. Semi-regularly throughout courses like this, students ask me, can I just write Python for the rest of your life? And yes, in fact, you can. That's totally fine, right? There could be times where you want your code to run 12 times faster, and the only thing you have to do is translate code you've already written into C. This is the case that can happen. My closing anecdote before we break for dinner, which I think it is time for. Does that sound right? Okay. My closing anecdote before we break for dinner. I just reviewed a pretty interesting paper. It was on performance-accelerated time series analysis. And time series analysis is one of the algorithms that sort of exists in the machine learning space now. And it used to just be done in like economics, or like maybe the biologists did it, like ecology, something like that. I don't know. Do you know, Thomas? Did you use it ever?
It would be like economics, probably.
Okay, so stock market, right? Yeah. A stock market, and I'm pretty sure it's used for like predator-prey relations and stuff like that. But hey, the stock market. Okay. There's some like high performance. There's a high performance Python compiler, the Numba compiler, that compiles it straight into C, then compiles to C, right? So you can always just use one of those. But anyways, there were 4 tools in this article, and essentially they pushed really, really high performance on machine learning payloads while working with base Python code. And they just used existing tool chains to either go to CUDA C++ or just vanilla C with Numba. So you can really crank your performance if you write the subset of Python operations that the people that write these compilers expect you to write. And I don't know what those are. And it's probably not this, because I don't think they work with iterators, but I think it's every single data frame you've ever seen in your life, every single neural network, all that stuff will be accelerated. So anyways, I think you're going 12 times faster unless you're doing that stuff. Speaking of 12 times faster, let's get to dinner 12 times faster than the business students. Ready to go. Do you think they're ahead of us? Are there more of them than us? Do they outnumber us?
There are usually more of them than us.
But we're cooler.
This is true.
Oh, I have to pause everything. Pause. Hold on. I should be recording this. Yes? Okay. Well, I guess they could be listening. That's fine. So base 64 encoding is a way of taking binary information and representing it in a printable format. When is this really useful? Well, the most common use case of which I'm aware is when you have an RSA key, which is the thing we're doing, right? So when you have an RSA key, it's some number, and the number has 4,096 bits in it, right? Oh, and it's actually not some number, it's a large number of numbers, because you save the primes, and you save, so you save a lot of information, right? And so it's these big text files in terms of hundreds to thousands of characters, not in terms of millions of characters, right? But they're just storing binary information in a way that you can move through, like the text editor. So you take 6 bits at a time, and 6 bits at a time, there's 64 such bits. That's why it's called base 64. You have 26 capital and lowercase printing letters, which adds up to 52. You have 0 through 9, and then you usually use like plus and comma or something, like other obviously printing characters. And so you make your information only 33% bigger, but you have no non-printing characters in it. It's this unbelievably useful way to store information. Do you use Quarto Markdown?
No, I was just going to
Yeah.
add for that, the midterm, instead of being required, can you make it optional?
Yeah, so I will give you what the midterm is and whatever it is. I will figure out some responsible way to give it to you. But essentially what it's going to be is, and
It's also really useful if you want to, for a bunch of JavaScript stuff for some reason.
yes. So why is it? This is why I asked about Quarto Markdown. When I embed images in HTML files, it stores them in base 64 because the HTML file, it's a text standard, right? All of the 64 characters are text, so you can input binary information in 6 times fewer characters using base 64. It's super cool. Here's an example of a text file that contains non-printing characters. There are spaces in here. This thing is 157 characters. Not too big, not too little. I cannot tweet that, but I can text it, right? It's in the 140 to 160 range. Presumably this works. There it is in only printing characters. That is the same information. You don't believe me, that's okay. Oops, that's not a command. Max.b, okay. And I think what I can do is I can base 64 decode that, and I can get the original back. So this is how like everything that moves over wires is stored, because it is only a little bit bigger, it is ludicrously easy to use, and it is dramatically more information dense than hex. You don't believe me?
Email attachments?
Mm-hmm.
Aren't email attachments base 64 encoded?
I don't know how email works. Do you know how email works?
I have no idea.
I would assume email's binary.
I like not to think about how email works.
It is, by the way, okay, so one of the examples of a capstone project, and here was one that I thought was cool. You all have heard of Instagram, which I hate. It's like one of the worst things that exists. And the reason it's awful is because it's closed source, and it's run by Mark Zuckerberg, who like is not a nice person and is probably not smarter than us, right? And so when you put those things together, you say, well, I should implement an open source peer-to-peer social media platform. And it's like, well, that sounds awesome, right? And that would be a good capstone because it would use machine learning and data engineering and software, right? So I was like, I'm gonna make them all implement LiveJournal. And everyone's like, how does that use ML? And I'd be like, I'm gonna do LiveJournal with anime avatars with computer vision. And they're like, that's a lot. And then that was the end of that. Okay.
Oh, honestly, I know because I gotta mention this speaking of an anime thing, because apparently an anime-based application that'll help you do your tax taxes where the avatar is this cute anime girl that like helps you do your taxes. I think it's one of the greatest things humanity did.
That sounds really great, and I'm really happy. I started watching anime unironically recently, and it's made me so happy. Like, I resisted for so long because I knew weird people did it. But weird people also listen to emo music, and I'm doing that unironically now too. So like when I'm too sad, I watch anime. When I'm too happy, I listen to emo. And I'm nature's perfect organism, right? Anyways, so you can also store this in hex. And an astute student, as we love to say, I love saying that. I actually became a professor just so I could talk about hypothetical students. Base 64 is way more dense than hex dump. Hex is almost always stylized with some additional characters, right?
Isn't it bad if they don't use the same final two characters for base 64? Because I see this using plus and equals. And you
Yeah.
said comma before. Does that throw anything off or no? You can pick whatever.
Those two equal signs are very high density. They refer to the alignment of the 8-bit chunks to 6-bit chunks. And I don't remember the exact same thing they mean, but that means there's some number of like leading or trailing zeros. The base 64 standard exists somewhere, and I would look it up. Now, we do know one thing, which is we know that we encoded something that is 57 characters in size. I'm assuming 157 times 1.5 equals 250, and I don't know exactly, right? If I use 6 bits at a time to store 157 units of 8 bits in size, that is 157 times 8 divided by 6, which might not be evenly divisible. And I think those two equal signs denote how not divisible it is. And I know that's true because 4 6-bit chunks are present. No, I can't do it. What's the common denominator? This is actually modular math. I have to check. Okay. So there are 157. There's that many bits. So you need 210 characters, but the last character only represents 2 bits. It doesn't represent all 6 bits. So these 2 equals here denote that there are 2 2-bit things that are not being represented, kind of.
Okay, so they're not part of the 64-bit encoding, they're kind of splitting coming at the end.
They are part of the 64-bit encoding of a file, but they are not part of a 64-bit encoding of bits. They're representing how far misaligned you are.
Gotcha.
And I think what's 29 divided by times 8 divided by 6? I can't do any of this stuff. This one has a single equal termination, which means it's off by 1. No, I need to check the size. Did I already do 159?
You did.
Okay, so this is 2 different than that? Okay. And this one has no trailing zeros because it's exactly byte 6-bit chunk aligned. I don't know that there's a name of 6-bit chunks. I refer to 4-bit chunks as nibs and 8-bit chunks as bytes. I have no idea how to refer to a 6-bit chunk. It's not like a nib and a half or something, right? I guess you could call it like a nit or a bab. Anyways, the midterm is implement base 64. And you get most of the credit for going forwards and then full credit for also doing decryption. And I was not going to tell students they had to get the equal signs at the end right, but now that I'm looking at it, it seems pretty easy. Like, you can do that in 90 minutes, right? Because there's going to be a 90-minute midterm, right? What? It's one executable. That's a countable number of executables. It's a countable number of executables with a countable number of digits, or printing characters, you can base 64 your solution. I thought one of the fun ways to do the solution would be it has to encrypt itself in base 64 and then decrypt itself with itself. I thought that'd be fun, right? It's like, I don't know. I feel like I know how to have a good time. I'm going to go refill this, and then we're going to talk about finite numbers. Is that what we're going to do? Yeah. Is this where we were? Does that look familiar? You accidentally said you enjoyed lectures, and I don't feel that anymore.
Well, you didn't even have a midterm, right?
So I have now revealed that this, in fact, was a crypto algorithms class, right? Because it's a secret that it was an algorithms class, right? That's what the crypto was referring to the whole time. I know. I really do crack myself up. So one of the crypto algorithms was actually embedded in this slide. That's the term binary search. It's one of the algorithms. How do you figure out if you don't know what base you have, for example, or you don't know how big your numbers are, what the biggest number you can store is? Well, you don't keep adding 1 to it. You double it until it doesn't get bigger. And then instead of doubling it, you increase it by 50% in size, and then you increase it by 25% in size, right? The astute learner will realize that this is actually equivalent to setting specific bits. And then if you follow correct binary search, the way you'll do this is you will fill out a series of 1s, and you'll get to the exact maximum size in log of the max size base 2 squared divided by 2 operations, which is not very many. Did you not get to divide by 2? Okay. Why is that? Well, okay, I don't know how big something is, and it happens to be 16 bytes in size. No, let's do a silly example. Let's do 7. We've never worked with something with 7. We just worked with 6s and 8s, right? So you're working with something you don't actually know if it's base 64 or base 256, and it turns out it's base 128, but you don't know that, right? So what do? You take a number 1 and you double it. And you say, 2 is bigger than 1. Then you double it again and you say 4, 8, 16, 32, 64, 128, you roll over, and you get 0. And you say, if I make something bigger than 64, it gets smaller. And so you have 7 guesses, and you know that your maximum is between 64 and 128. So what do? Well, you guess in between the middle of those. Well, in between the middle of those things are 64 apart, so in the middle of them is 32 apart. So this is actually equivalent to setting the 6th and 5th bit of a binary representation, which is crazy, right? And then what you realize over time is you just keep setting the bits until you roll over. So in practice, you count up to the log base 2, you go over, you back off 1, and then you fill all of the 1s back. If it's a binary size, right? Not everything has to be storable in binary, and the example of this is base 64, which doesn't have the even binary storage size. Something that I think of a lot that doesn't fit evenly in binary is always the 26 alphabetical characters, right? There's either 26 or 52 of them. Neither of those is a power of 2. So if you're ever storing them with maximum encryption, either you're throwing out bits or things don't fit evenly, right? So that's how you'd use binary search. I'm not going to write that. That's very painful to write, right? This is a bit shift with tests dealing with overflow cases, and you really want to deal with the overflow cases where the answer is not what you expect, not just that it's smaller, because something might loop around partially. So whenever you're trying to figure out how big something is or where something is, you should always be trying to use binary search rather than incrementation. We are actually going to have to use brute force iteration in the first RSA example in a few weeks. And then I'm going to solve that problem next week with something called the extended Euclidean algorithm. It's right there in the name. I snuck it in there. Right? But if you refer to it as extended greatest common denominator, then people think they're doing number theory instead of algorithms, which they also don't care about. Right? Okay. Speaking of number theory, the thing that people don't care about, there exists a thing called a ring. What is a ring? The C integers are different from just bits in a following way that's quite important, actually. And it's the following way that's quite important that we already saw with sort of this type coercion. Sets of things, so if I just had a collection of values, those aren't really the same thing as numbers. Numbers have the additional benefit that operations are defined over them. It's a combination of a series of possible values and separately also some operations. So the uints and the ints actually have different plus minus times to bind all of these operations, right? They're connected. And so they are not rings. What they actually are the closest to is classes or objects, right? An integer is especially in Python, this is quite obvious. Why do I have Windows PowerShell open? So you can verify, for example, that the Python ints are in fact just objects of a class, right? This is not true in C, but this is simulated by the compiler, which keeps track of whether something is an int or a uint, and then appropriately selects a different bit shift value based on its size. And you experienced the slight headache of making sure your bit shifts do exactly what you wanted to in the macros assignment. But you will note in the macros assignment, because SHA-256 was designed in the 32-bit era, you probably just naturally got 32 bits a bunch of times when you didn't actually have to get them, so hopefully it was not too painful for you. But you did at least have to know with rotate that you were dealing with 32 of something. I'd like to reiterate it matters a lot that when you add two numbers together, they don't have to get bigger. This is weird. This is unhealthy. We can simulate this quite easily and just do a testing script. Have you all seen A2I before? That actually worked. Okay. A2I and A2 all. A2 long is very useful. I don't know what the A stands for. By convention, A is used to refer to a single printing character, and it probably either refers to ASCII, alphabetical, or alphanumerical, right? So that means alpha, which is like before they used the term string. I think this is what's used. I think A2I is quite a bit older than C. This is the C99, but this is quite recent actually, right? So this is just it's a pseudo built-in thing, and you can see it in standard lib.h. I realized how built-in A2I was in C when I wrote there was the x86-64 extension lecture. If you write A2I in C and then compile it to assembly code, the assembly code says A2I in it. So it's like an assembly primitive, but that's not true. It's not an assembly primitive. So somehow this thing is treated as if it's an assembly command. That was very surprising to me, and that suggests to me that A2I is much older than C. Let's go ahead and grab num.c, which might already exist. There it is. No real differences. And we note, I do have multiplication here. We'll change that over to plus for consistency. So we add two numbers together, we don't exactly get the same number, or we don't get a larger number. If we add 10 and 10 together, what do we get? Oh, right, I am returning it, okay. How do I see the return value of an executable? Do you remember? Does someone want to tell me? Okay. This was in the auto grader for macros. Echo, $sign is the escape character, percent is the name of the most recent return value. It's 20. Everything does have a return value, even if it's not obvious. All of my C functions return 0 because by convention that's what you should do when there's not a disaster.
So you said percent, but you meant question mark?
I did mean question mark, thank you. Yeah, $, question mark, and percent are the same characters in my brain, which is very, very annoying if you're writing LaTeX and Markdown. Because I think, is percent like an HTML escape character or something? And then $'s a LaTeX escape character?
What's LaTeX?
LaTeX is the mathematical styling language that's used for this stuff. That's LaTeX. And
LaTeX is used to enclose mathjacks.
yeah.
HTML is an ampersand.
Yeah, okay, I understand. I misspoke. I said LaTeX was for the mathematicians. That was true, but it was invented by Leslie Lamport, who won a Turing Award for doing network theory, and was one of the other people that invented the internet. But that person didn't really invent the internet. And so I think, like, at some point in time, when moving from papers being things that people wrote and handed to each other, at some point there was typewriters, and then at some point they started getting typed in computers. We got the first things that were like, here is a scripting language that tells the computer what to print. And I think LaTeX was one of the early ones of those, and the other one was PostScript. LaTeX has become so ubiquitous. I mentioned I talked to the mathematicians today. They type LaTeX plain text commands directly into Google Drive documents storing meeting minutes. And their brains perceive them as the mathematical command. So they still use plain text. They use uncompiled LaTeX as their lingua franca. And I would have thought that was crazy if I hadn't had a conversation with one of my friends over Discord where we didn't have the LaTeX bot installed. And we just wrote LaTeX back and forth to each other. We didn't use English, right? So LaTeX is this really rich way to communicate mathematical thoughts. And this specific type of mathematical thoughts is to me, it is quite difficult to give the notion of does not imply, but I can just write that command, which is next right arrow, or not, capital right arrow for the double arrows. And if I saw someone write that in an email, I would know they means this does not imply that thing. I am throwing LaTeX at you like crazy, because I saw a ton of it on Stack Overflow when I was trying to learn to solve problems. And I'm worried if you don't see enough LaTeX in this class, you're never going to see it, right? One of the comments I did get back when I taught a not even conceptually related class with the exact same name to the data scientists last year is they said, it was really nice you taught us a bunch of set theory operators because now we understand Stack Overflow answers to SQL questions written by people that know set theory. And I was like, great, didn't know that's what I was teaching. But what that meant is I've doubled down very aggressively on showing you these, I perceive them as quite annoying. I just had a conversation today with my undergraduates about this is a very annoying way to write things if you don't know it. And you will never know it if I don't show it to you now and explain it to you while you can ask the questions. And one of the other examples, and so I'll give you an example of a time this was confusing. I wrote a to the power m minus 1, and then there were 3 things, which is in LaTeX \equiv for equivalent. And so it said a to the m minus 1, equiv 1, mod n. And 1 mod n is always 1 for all values, right? But there's this notion of saying equivalence mod n means you apply mod to both sides and then they're equal. And I remember in undergrad never being able to remember what that meant, and I just wrote mod on both sides of a standard equal sign, which is logically identical, but more characters to type. And my preference would be that we always just do say mod, right? But there's this culture that developed around using LaTeX notation for everything. And so like if you just look up things we're learning in this class on Wikipedia or Stack Overflow, or you ask someone why your SHA key doesn't work and they have a classical education, they're going to write back to you in LaTeX. You can communicate with like Italian mathematicians in LaTeX if they don't know English.
I'm sorry,
Mhm.
LaTeX is not that, it's what you wrote to get that, or
They're equivalent. So as with,
it's interpreted.
yeah, I've used the notion like Quarto Markdown. There is there's the script and there's the render. It's very similar to Markdown. If it came out today, it would be Markdown, and in fact, most Markdown languages accept LaTeX in them. So now it's a subset of Markdown practically. I don't write LaTeX; it just comes out in Markdown. This is how it's stylized. A lot of people really liked overleaf. Hello, LaTeX. Right, as opposed to what you see is what you get. So it is not Microsoft Word. It is the way of, yeah, it's a way of styling text.
I'm sorry, that's pronounced LaTeX, not LaTeX.
Yes, so I actually thought everyone would say latex, and in my undergraduate institution, every single person said LaTeX, and I got made fun of. And then it turns out maybe that was also only my undergraduate said LaTeX. So I say LaTeX and people stopped making fun of me, but I think if you say latex, that's fine. I haven't heard latex. I think that's a bit much, because latex is already taken.
LaTeX sounds so bougie, it's legit. So I have a question.
Yeah.
If you say latex, the math majors will make fun of you at UCSB.
Okay, or maybe it's the math majors, because yeah.
The science majors will question themselves and won't make fun of you though.
Is there like a quick online LaTeX thing? Right, so historically it's been installed and now it's just built into every Markdown. So if you have RStudio on your device from Data 505, it's quite likely you can do $\equiv, close $, and you'll get the equivalence thing. And
If you have RStudio installed and you don't install LaTeX, you're just not able to into PDF.
really?
Yeah.
Oh, it's its PDF engine. Okay, right. So historically, LaTeX took text files into PDF, and it's not really used for that in my view anymore, because PDF has been a dead format for 10 years. But you're learning, and I remember talking to Hendrik Oren, and I looked at his slides. I was like, "Oh, you're a math major, right?" So I immediately looked at it. I was like, "Oh, that's Beamer LaTeX," because I'd seen so many slides in that exact format before. So this is MathJax, which Ari mentioned, which is a JavaScript CDN that takes LaTeX into.
I think MathJax is just the name of the it's just the name of the I guess it is cross-browser JavaScript library. Oh, it's MathML.
Oh, this is MathML, which I don't know what that means. What's ML stand for?
Markup language. It's just XML for math. I mean, look at that. It's a bunch of XML for math.
I mean, I see that it's math. Oh, that says MathJax. Don't look into this too long. Well, I mean, I would. I looked into this for a long time. The first time I got it to work, I was like, class MREL. Yeah, I think I'm not smart enough to figure this out right now. Something that was very interesting. I was working on other slides, not these slides. So there's cool slides I made. They're like for 3 weeks. I would have pulled them up for examples today. And I couldn't check them into GitHub last night because the internet in my apartment was down, which means I couldn't see any of my CDNs. Turns out I have some library that renders all this stuff to LaTeX on my computer, but it's a different mathematical library. And so the slides loaded more slowly and then everything worked. Do you know what that is? Is there something like built in Firefox or something?
So apparently, MathJax, depending on what you have available, will use math fonts.
Okay.
It's possible that it was pulling the math fonts, and if it was unable to do the math fonts, then I'm not entirely sure. Oh, it may have just been rendering SVG.
It may have been rendering SVG.
What do you mean by CDN?
What is a CDN? It's a
Content Delivery Network.
Is that what
That's what I'm thinking of.
yeah.
I don't think there is a CDN
It's very easy. Let's check.
By opening the network tab.
Sorry, we're accidentally doing useful skills now instead of number theory. Okay. GitHub asked me why I teach my classes this way, and I said, what if you just need to teach some front-end development for like 15 minutes, right? Like, you need to have an example in front of you. Is this what I meant to do?
Yes, you want the network tab of the different dev tools.
Do I?
Yes.
Do I not just want to download this and look at it in a text editor? Or is that how boomers do things?
I don't think you will find anything interesting if you download it in your text editor.
You don't think so? I'm opening it. Why did it say .htm? That's suspicious. You look at it, you have the same thing. And all the rest of you look at it too if you want.
It downloads a bunch of math fonts.
It downloads the
Oh,
math
there.
fonts. I feel pretty good about saying this is a CDN.
It uses Cloudflare CDN, but it's just to download the fonts. It does the
We're
actual-
saying that doesn't count as using a CDN?
It doesn't count as what you were sort of implying, which is that the math is all rendered on someone else's computer. You're downloading the fonts from someone else's computer, but the rendering is all done on your machine using this like cockamamie JavaScript library.
Okay, I'm willing to accept that characterization, but only because I don't want to fight about it right now.
So I can tell you the names of the files it downloads.
I'm sure you can. And I'm proud of you for that. Okay. And you should be proud of yourself too. I taught the theory of computing class, and I introduced that as a 3-language class, Markdown, Python, LaTeX. And I expressed everything in all 3. I was a dogmatic, you should write all of your mathematical notation in HTML enthusiast until I attempted to encode automata theory in HTML and gave up instantly. It was staggeringly impossible. And then I went to do it in LaTeX, and it was really easy. So I had removed all of LaTeX from my tech stack last year, and I put it back in this year. And I do think you'll see it specifically on Stack Overflow. I see a lot of LaTeX on Stack Overflow for like where it does not belong. Okay. All right, let's add some numbers together. Okay. Do we think I can get like a compile error? Oh, I can probably just run a.out with no inputs. Okay. So, C functions have C executables written in C, which are not C executables. Once they're an executable, they're an executable. I think that stands for executable load format. That's the first 10 printing characters of a.out. It's an ELF, that's its file type. So that thing is not a C executable. That is an ELF that was written in C and compiled into an ELF using GCC. Okay, executables return some value, and they return some value to the operating system when they're done. The operating system exposes that value to the user, I am the user, through the $%. Did I get, yeah? Head a.out executed without issue, so it returns 0, no problem. A.out seg faults. Presumably 139 means segmentation faults. I don't know, I should probably know that. It's not like I have any idea.
You did GCC on the compiler before. You could run echo right after you got 0. You not need to run the program, or just work on what you compiled, or what you pasted previously.
Tell me what to type in and we'll talk about it.
So you just did GCC something. I don't know what you did, and then you just ran echo right after that, and it just I think you did that. Like you ran that, and I believe you just did echo. No, like not the same line, like the next line. You did it without running anything. Yeah.
GCC is an executable that's returning 0.
Oh.
If returned an error because it wasn't provided with any inputs. How's it 2? No error. Yes, it's important to remember GCC is an executable that creates executables. It is a higher order executable. There are also executables that run executables. There's one example. Time. Random Python executable, right? There are executables that run executables that run executables. Okay, we're not going to do functional programming in the command line. We're going to cut ourselves off. We've been having too much fun tonight, right? Okay. I think we can all agree we've had too much fun. No one would argue with that. Okay. I added 200 and 200 together. Usually we'd expect that resultant value to be larger than 200. It is not. I bet you don't even remember what's in a.out. Not to worry. Here, I'll show you what's in a.out, and you can look at it. This is not particularly human readable, but hey, in fact, there's some printing text in there, right? I think we can all tell what this is doing, but if we can't, we can look at the C code that compiled it. The number of arguments provided, the vector of the strings of arguments. Why do I say vector? Because there's a B there. That's why I'm saying vector. Otherwise, I would say either array or buffer. My preference is to say array or buffer. You can say whatever you want. The undergraduates have been raking me over the coals for intermingling buffer and array. It's the same thing. If it seems weird to you, let me know what your preference is. They've standardized me onto array. They are not lists. We're going to learn about lists when we learn the data structure. Okay, so this is a vector of arguments. The arguments are characters. So this is an array of arrays of characters. Okay. We take the first argument, or I guess we take the 1th argument. The first argument is the name of the executable, or v0 is the name of the executable. So we take the 1th argument and we store it in x. We take the 2nd argument and we store it in y. And we add them together. And by convention, we would expect addition to cause things to be larger. And in fact, in many cases, addition does cause things to be larger. Yes. It's quite large. How big is it? It's that big, however big that is. Does that say 22,000 characters? I don't remember what word count does. Is that something right? Did you say something?
I didn't say anything.
Did someone say something? I heard an idea that might have been interesting. Did you say something? You didn't say anything? Okay. Should you have said something? Missed your chance. Okay. There's a lot of A's there. Capital A is the first letter of the alphabet. I suspect that's encoding 0, but there's a ton of zeros in there. I'm wondering if that's what's going on. Wait, we can check. Yeah, there's a lot of zeros at the end. Wonder why there's so many zeros. I don't really know how C works, so this is beyond my knowledge. Okay. This addition is a implicitly occurring modulo. Here is an example of something that you can do in LaTeX and cannot do in HTML. That is a script n with a subscript for which the subscript has a superscript. Go ahead and type that into HTML and let me know what happens. And I think the answer is a different thing in every browser and every CSS environment, probably. I'm sure you can do this in HTML if you're a front-end web developer. I don't know how, so I did this. I just think it looks great because I actually don't know what 2 to the 8th is, but I know that's clearly representing something that can be stored in 8 bits of memory. And I can figure out what 2 to the 8th is pretty quickly. But in a way, that is saving my brain from having to compile 2 to the 8th. right? I'm using the sort of same delayed execution that Python uses, right? So, operations on uint 8t values are equivalent to operations on the natural numbers modulo 2 to the 8th, which means that you do all of the operations as you would normally, but before you return the value, you take it mod 2 to the 8th. And in fact, you take the modulo value every single time you store the value. This is not too remarkable and not too exciting, but was, SHA-256 relevant, right? This is how we prevented our values from getting larger. This is going to matter a whole lot when we need numbers much bigger than that to store information with RSA. Okay. Here it is. This is the equivalence. This expression is LaTeX. What makes it LaTeX? This plus is not a standard script plus. These values are italicized, right? So this is mathematical notation. That is not any character I'm aware of. To me, it looks like an image, and I perceive it as an image because I think the gray value is actually the wrong in there. I think there's aliasing on this, so there's something going on in here. A plus B is equivalent to A plus B mod 2 to the n. Okay, so if you need to know how big of a thing you can store in a number, one of the ways you can do it is to test it. The other way is you can include limits.h, and it will expose these constants. This is always confusing to me because I have very aggressively removed all use of int from my C code. And limits.h uses the old C names. That said, I only need to know what int max is if I'm not using uint 64t, because I know what a uint 64t is, right? So it makes sense. When should you use these things? Every single time you are dealing with overflow, you should always use something in limits.h because it is a way of self-documenting your code. And self-documenting code is good. Should you actually include the limits.h library? No, you should calculate the constant in a define and then use it within your code, most likely. These are getting into software engineering stuff, and I promise to not teach software engineering because the software engineering fairy will come and make me learn C#. Here is the problem we are trying to solve. GitHub has asked us to use the command sh8 keygen to specify the type RSA, to specify the bit size 4096T, and then you're supposed to put a note on all of your sh8 keygens, or SSH keygens. And that 4096 is a huge problem because that is an absolutely enormous number, and we don't have a built-in way to deal with things that are that big or even close to that big. That is 64 64-bit integers. It's too much. We're going to have to write a library to deal with this, or use someone else's library. I wrote my own library, and in the fullness of time, I will have strong performance measurements comparing me to this library. Unfortunately, the library I selected to compare my performance against apparently is the fastest in the world by far, so I should have been a little more clever about that. But I bet I can be faster than Python, right? Surely I can beat Python. And if I can't beat Python, I'm going to race R. So that's how I'm going to do it. We'll keep choosing more esoteric languages. This is sh8 keygen. SSH is, I wish I remembered what it stood for. It's like secure shell? I don't know. To me, SSH is just an entry-level category. It's just secure shell?
Yep.
Crazy. No, it's not. It's Open SSH Remote Login
What does
Client.
the SSH and Open SSH stand for?
It stands for SSH. Okay. You should look at this. Why should you look at this? There is one form of cryptographic problem I have classified as out of scope for this class. Those are side channel attacks. Side channel attacks are the reason Intel is less money than NVIDIA. They're a big deal. They're the reason Mozilla Firefox lost the browser world, despite being better in every single measures except one, which was vulnerability. Do you object to that?
It's also not very good at keeping up with web standards.
No, web standards are not very good at keeping up with Mozilla. It's the open source browser. It's correct by construction. I'm really popular with the Mozilla people for saying stuff like that.
I'm using Firefox, kind of.
Are you? Which Fox are you using?
I'm using Zen.
Okay, that's fine. I guess I won't update the favorite student rankings, but okay. ED25519 is the thing I plan to do in Rust. I do that. It's very cool. All the kids love it these days because they don't appreciate RSA. I don't know, they don't appreciate. I still love RSA because it has something in it called the extended Euclidean algorithm. This is an algorithms class, right? So GitHub is recommending you don't use RSA anymore. RSA includes strong learning outcomes, and it is historically interesting. So I taught RSA for that reason this term. Also, those I always call it ECDSA. It's an elliptic curve. It's elliptic curve cryptography. It's called elliptic curve cryptography. Google it, look it up if you find it interesting. I find it less interesting than RSA. Elliptic curve cryptography does not use 4096 bits. So if I was going to make you write a 4096-bit library, I couldn't let you use the cool new cryptographic algorithm. So we're doing something that's older, worse, and harder, right? It's C89 again, right? But in fact, it is still an accepted standard for GitHub. Last I heard, the largest RSA keys that had been broken ever under any circumstances were around 750 bits. And how much harder is it to crack something that is 4,000 bits than 750 bits? Much, much harder, right? These things are invincible. The thing that 4,096 bits is actually protecting me from is the assumption that our RSA algorithms contain a mistake we haven't detected yet that caused them to be less safe in a way we did not anticipate. This is the same form of weakness SHA-256 might have. Maybe it's not quite random and no one ever noticed. And if it's not quite random and no one ever noticed, then we're in big trouble. But if you have 4,096 bits of encryption and it's not quite random and no one ever noticed, you might just still be secure anyways, right? So that's what the 4096 is for. I'm gonna run that command. See, it doesn't have the nice copy-paste thing like my website. I'm better than GitHub. Okay. I shouldn't have said that. That seems mean. That's too much, even for me. Okay. Did you notice how that wasn't instantaneous? I pressed the key and then I took it. RSA is hard, right? That was a hard thing to do. This is an industry standard tool and it was not instantaneous. That is unheard of, right? I'm going to store it in the default place. You get a random arc. You notice that wasn't instantaneous. I think I can probably drop down to 1024. And that one was instantaneous. So I'm going to use a 1024 key because it's easier to see. Why did I type that?
What is a random mark?
No idea. I like Reddit once and I like lost interest. There's some way you want to be able to tell your keys apart without being able to look at the actual key because that's like super insecure to look at this secret information. So it has like...
representation, just a little ASCII image.
Yeah, it's based on it somehow. I would have to look it up. Yeah, me not caring about this is why I got banned from teaching data visualization class. But look, it's an SHA-256 mention. So presumably this is like the 256 hash of the key or something. I don't know. What's going on here? Under no circumstances should you ever even entertain looking at a private key you're ever going to use at all. I'm going to show this to you, and then I'm going to delete it, and I'm never going to think about it ever again. What you should in fact be doing is you should only be fooling around with this stuff inside a Podman container, and then you should never use that Podman container to connect to anything under any circumstances. Now you might think, oh, I'm not going to use that key. No, if there's any weaknesses in any aspect of your system, generating this key and using it once at all is going to expose weaknesses. So like, don't screw around with this stuff, containerize it. I verified that I had internal integrity on this system, and even I would still rather not do Podman. The only reason I'm not throwing this in a Podman container and using the latest version is because I had performance problems and I'm teaching a class. So you probably don't like have something on your computer you have to protect that much, but like the degree to which you should have an extreme fixation on safety and security around RSA keys is very high. So never do this except in this class. We're allowed to do unsafe things in this class because we're learning about them. This is the key. It's pretty big. Now, this is a 1024-bit key. I would estimate there are many more than 1024 bits of information on the screen, and I would point out that this is base 64 encoded. This is storing a lot of other stuff, and in fact, I do know how to look at all of the internals on this, and I'm not going to do it right now. It was quite an involved process. You are allowed to look at this. This thing's totally insecure. No one cares about this at all. This is the public key. This is what you can show your friends, and you give your friends this. They drop it into RSA. They make an encrypted text, and then you decrypt it with a private key. That's how this all works. I wanted you to get a sense of scale of how much information was getting passed around here, right? This is some large, well, here we can look at it. That is 3,081 base 64 values, which is 3,081 divided by 6 times 8 bits. So it's 4.4 thousand byte. No, it's the other direction. It's, why can I not do math right now? It's 2,200 bytes. I have to check. Oh no. This is why Python allows both quotes, by the way. Like literally, like I checked. Oh, what? No, I didn't evaluate it. Oh! That was the complete wrong solution to what I did. Okay, that seems wrong. What's this? I think there's 2,600 bytes of information encoded there. That's what I think, because there should be fewer bytes than characters, because you need more characters than bytes.
Does that add to the double equals, the 0.75?
Yes. I have no idea. I would read the standard. And the standard was confusing. I read it before class, and it didn't help. It's good to be confused. We deserve to suffer. I was talking to my partner last night, because we were watching anime together, and we were discussing the meaning of life, and I said, it's easy, it's to suffer. And apparently that's not what you're supposed to say. It turns out it's to love your partner. But I realized that. Moving on. Wait, were there questions about it?
I have a question.
Yeah.
So not to be that guy.
Yeah.
But when it's been bothering me.
Yeah.
So when you say like these things are equivalent to each other and you use the 3 lines,
Yes.
isn't that congruent and not equivalent?
Probably.
To be
Yeah.
clear?
I don't know.
Okay.
Would you say congruent?
I would say congruent
Okay.
because they're not equivalent. Like when you have A plus B is equivalent to A plus B mod 2 to the power of n. They're not equivalent.
Yeah. It's congruence mod n, right? Yeah, that's what you're saying. Yes. Yeah.
Okay, thank you.
Yeah. So
Sorry.
yeah, no, I should issue a correction. I should have been saying congruent the entire time. I'm recalling this now.
But when you put it in LaTeX, is it actually like equiv?
It's literally equiv, yeah.
Okay, that's awesome.
I've heard both before, like in discrete math, like, yeah, some people use it like in, I don't know, like, if there's a,
And it's not, I mean, it's not important, but
yeah,
it
it's
was just,
like a terminology kind of thing,
yeah.
I'm pretty sure I used congruent in undergrad and equivalent in grad school. I bet it's
Okay.
regional.
It's not an expression.
Yeah. Well, we all went to the State University of New York, Albany, right?
It says also known as congruence modula, a little AI overview. But what is congruent?
It means equivalent.
You ever get 2 triangles over the same?
it's the mathematician's fault for making it.
We say congruent. You see what we have to work with here. Isn't equivalence right? No, okay, so equivalence is a superset of congruence. Congruent is more precise, but they are equally accurate.
All right.
And so the reason the LaTeX marker is equivalence is because it's used for non-congruent equivalence, because you would also use it between functions. I have used equivalence between automata that recognize the same language using different computation. And this is distinct from numbers being congruent under some mod. But the operator is the same. I would like an issue a correction to my previous correction. I was in fact correct the whole time.
This is a major stretch that maybe Mario would know. Is the JavaScript triple equals originating from LaTeX triple?
I think the JavaScript triple equals originates from the fact that double equals is not a comparator of truth, but of truthiness. I don't think triple equals is a JavaScript operator.
Well, we can check, right? Here we go. Inspect. Okay, so we all know that 1 equals 1, right? But that's math. That's not programming.
That's SQL.
That's SQL, right? So that's allowed. Is this the issue?
Maybe double equals like 1 equals or something? I think
Wait.
double equals
Oh, because there's no ints.
Yeah.
Oh, I'm so mad right now. Sorry, what was your question?
I think the double equals would have thrown that off or something, right? Double equals is not necessary.
If you do 1 double equals 1 quotes, it will work.
Okay, I don't like JavaScript anymore. I thought me and JavaScript were
Did you not
fine.
know this? This is why most people don't like JavaScript.
No, I didn't like it. Why didn't I like JavaScript? Oh, because it doesn't have integers. I'm a huge integer fan.
You can always just everything with math.floor.
Well, you can also do the there's some way to force them to integers without using floor. I don't remember what it is. It was like really non-intuitive to me. Dang it, I don't know. There's a better way than floor. I looked this up when I was doing JavaScript because I just added it to the end of all my numbers. Okay. Still today. These are the review slides of our previous things. Okay. So you get 11 slides off. Don't spend them all in one place, right? It takes me minutes to write one of these slides, so this is a lot of labor I'm just throwing away here. Now, it's true I had already written those slides and just copy-pasted them over. But I didn't know when we would get to them in lecture today. We need big numbers, huge, enormous. 2 to the 4,096 is a large number. It's a larger number than I can conceive, right? I think it's dramatically larger than anything I can work with evenly. I was talking to my partner about nanochemistry, nanocrystals, which are quantum defined in 3 dimensions. So we were talking about Avogadro's number, which is only 10 to the 23rd. Like, that is dramatically, like, there are many fewer than 2 to the 4096 subatomic particles in my body, or something like that. Right? Like, these numbers don't make sense. Okay, so do you all remember our example of when I decided to not like Python anymore? Because I was just not liking JavaScript. Now we're back to not liking Python. And here we have the example. You don't have to not like Python. I always say students are allowed to like Python in my classes. Yeah, let's just open it. Okay. So we do 69.3 percent 12. And I just, this seems like one that a modern programming language could get right. Like, this does not seem like hard math. And do you all know that there's examples from Data 505? There was the Heights data set in the first day. And I think the self-reported height of self-identified men is 69.3 inches in this height data set, right? That like only men responded to or something, right? And so I played It's Raining Men by the Weather Girls. We have fun down in Salem, right? Okay, you're not allowed to have fun up here. Okay, I'm not gonna say that. I mean, we have fun this day, right? But like, I could also teach Mondays, right? You could get 2 Calvins a week. There's actually a rule against that. Okay, so this is bad, and no problem. We are going to fix it using a little thing I like to call arithmetic, right?
Why is that bad?
It's bad because it's wrong.
So what should just be 9.3?
Yes. It can do that, right? And these are equivalent to multiplying that by 10 and then dividing by 10, right? So I should do single divide, right? And we're losing a digit. I don't know. Anyways. Does it have to be in parens? Did I type C? Yeah, that's a C. Okay. I don't know what I'm doing. My position on computers is that the only thing we have them for is that they can repeatedly do extremely tedious mathematical operations without making mistakes. And so when a computer makes a mathematical mistake, I instantly fly into a frothing rage and can't think about anything other than how much I want to do arithmetic myself better than the computer. And the only thing that slakes my bloodthirst, I don't know, is... Okay, follow along. Are you taking notes? Okay, the only thing that can get me back in the game is solving the problem myself. So I'm going to solve this using C. And I'm going to use a motivating example, sorry.
Is Python's open source? You're better just fixing it in Python?
So it's actually compliant with a floating point standard.
Okay.
So I have to write a request for comment,
Gotcha.
which I will do. I will simply submit these slides. Be like, this is my comment. And they'll be like, thank you. Please lose my email address. Right. So I'm using a motivating example. The motivating example is subtraction. Why is that? So in the lab section that is attached to this, I provide the subtraction example. So all of my examples are based on subtraction. Subtraction is one thought harder than addition. So I provide subtraction, ask you to write addition, then you know how to do it, and then I ask you to do multiplication, which is the hard thing, right? But multiplication is not that bad. So I used the motivating example of someone whose height I knew, which is Aja Wilson, who plays for the Las Vegas whatever. I don't know how the WNBA works, but I know we don't have a team yet, but might get one in Portland, which means I think I'm rooting for the Seattle Storm. No? Who am I rooting
Why
for?
would you root for the Portland?
Because there isn't one yet.
There is going to be one.
There's going to be one, I've heard.
No, there
I read it in Willamette.
It's coming.
Oh, it's coming? What's its name?
That's the name.
Portland WNBA team. It's like how there was a Washington football team.
That's great. Anyways, let's go Portland WNBA team. Okay. And so I thought, well, I don't know how much taller 6'4" is than 5'9.3" inches. There is a section on the course evaluations that says something to the effect of other cultures. Metric solves this problem, by the way. Okay, so we can convert between integers and non-integers pretty evenly. There's not really a graceful way to convert 9.3 inches into a number of feet. Like, obviously that should be painful to us, right? And I do it in a computer, but I just demonstrated that computers can't do division, right? That's the motivating example, right? So I'm unwilling to do that, and so I'm actually going to write code to solve this problem. But the coding language I'm going to use is English, and I'm actually going to program humans to solve this problem, right? And the human I'm going to program to solve this problem is me. I did all of this myself by hand. It specifies here that it's fun, and that's on slides. So that is a You are required to know that this is fun if you were asked on a midterm, which I canceled the midterm, so you all owe me either a favor or not. Okay. I've used this notation of just moving the dot around. So this is the inches before the decimal point, this is the inches after the decimal point. I don't know if that's clear. It was a convenient shorthand, so I've adopted it. This is not 640 minus 593, which is trivially 47, right? Because some of those numbers are base 10 and some of them are base 12. This is pretty useful to us if we're trying to get good at thinking about going back and forth between bases, which we're probably going to have to do to solve every problem ever we experience in a computer, right? Okay, so the way I perform my long subtraction is these decimal inches are base 10. So what I need to do is I need to find the value such that when added to 3 gives me 0. Now, incidentally, when I was hanging out as a 6-year-old or however old you are when you learn subtraction, probably less than 6, when I was 0, they don't tell you you're doing modular arithmetic, but secretly you've been doing it the whole time if you've been doing your subtraction digit-wise. So 7 plus 3 equals 0, but I have a little thing I like to call a carry value. They're named after John Kerry, who ran for president in 2004. That's not true. Don't write that down. Okay. There's no such carry value here because we didn't have one carried over from a previous computation. So the lowest order bit, or the least significant bit, these are not bits, these are digits. The least significant digit does not deal with a carry digit. 7 plus 3 equals 0. And 7 plus 3 actually equals 10, so we put a 1 over here. Okay. Now, we might be thinking, this looks super easy, right? All we have to do is put something here, such that 1 plus 9 equals 4, so we need to put some value here, so that that adds up to 10. But the problem is, these inches are actually in base 12, so we have to think about how to think about things base 12. And I love thinking about things base 12 because the prime factorization of base 12 contains both 3 and 4, and I love thinking about prime factorizations. So, in order to add up to 4, if I start with 1 and 9, 1 and 9 take me to 10. I do not roll over 10, so I do not simply put a 4 here. Rather, I have to put a 6 there, because 6 plus 1 plus 9 mod 12 is 4. This matches our exact intuitive sense that someone that is about 6'4" is about 6 inches taller than someone that is about 5'10". We understand it intuitively. Writing the algorithm is miserable. Did you see how painful that was? Right? So, the value I'm going to put here is 6. 6 plus 1 plus 9 mod 12 is 4, and then I'm going to set this carry bit. Does that make sense? Okay. I used a height example because we can use our intuition.
Why is it mod 12?
It's mod 12 because we're converting inches into feet. Right. Someone that is 6'4" is 6 inches taller than someone that is 5'10".
Just curious, in like a computer to do this, is it quicker to just convert 2 inches, do the math, convert back to feet and inches? Or is it faster to do it this way?
If I were implementing a computer to do this, I don't know what I would do. I would probably use whatever the data frame operations are present, and the fastest data frames I'm aware of are pullers, which is a Rust backend for a Python front end, and I would literally just look at their source code and see if they have a height type. For this application, you're dealing with this fundamental problem that you're going back and forth in between integers and decimal values, and to my mind, there's no graceful way to do that. The way I'm going to implement a solution to this is I'm going to do carry bits within integers only and have an integer for each one of the fields. But I think that's only optimal if you know you're exactly getting single-digit feet and you're getting at most 1 decimal digit. So I would have to think about it more than that. I don't know that people add heights in computers ever. I'm guessing they just rip everything to centimeters once and then work in centimeters. Just doesn't make sense to not use centimeters if they exist. Because this would be trivial in centimeters, right? It would be a naive subtraction. Okay. So I put a 6 there. That also cleared the carry bit. It's done now. But that means I have to carry over one thing. And what does that carry represent? Well, someone can be 5 foot something and not be a full height, or not, can be 5 foot something and not be a full foot shorter than someone that is 6 foot something, because of the leftover values. And so if we trigger the carry, that means that the inch value of the shorter person is larger than the inch value of the taller person, which means that they are 1 foot less apart than the most significant digit would represent. So we add these up. 1 plus 5 equals 6. Any 0 goes here. This is non-modular because feet has no maximum. If we happen to have, what is a famously tall character? A beanstalk. I don't know, beanstalks are tall, right? If I were comparing the height of a human to a beanstalk, and the beanstalk were, for example, 12 parsecs tall, right? I would simply have a very large number of feet, much like a millipede. Okay. The takeaway is that WNBA players are tall, and that we can break numbers into smaller ranges when performing operations. In this case, I used a tenths of inches, a ones of inches. It's not really a ones of inches, right? Because I was going to put 11 in there. It's just inches. If I were to give my height, I could say I'm 5'10", or I could say I'm 5A and use hexadecimal encoding to store my height. And that's allowed. No one can stop you because you report your own height. Now, if you go to the...
Very unhappy with you reporting a hexadecimal height.
The DMV is very opinionated on many things I report to them, and I think that's good for them, right? Okay, we have a 1's digit, we have a 12's digit. Okay. Here's the code. So, Rohan, you asked how I did this. This is how I did it. This is a buffer. Let's run this. And I have header already. I'm gonna nuke my existing header and get a new one. Here's the header. Oh, sorry, I meant, oh no. I didn't mean to make an unpronounceable sound. You know, sometimes you're just hanging out with your friends and you like make an unpronounceable sound and they're like, what was that? Okay. All right, so what are we going to do here? Why did I make a buffer instead of writing 6 integers? I don't know. It seemed easier to me at the time. I was probably getting a lot of questions about buffers and was trying to be obnoxious on purpose. I don't know if you've all known this, but sometimes I intentionally make poor design decisions to annoy my students. I just can't help myself. So here's an intentionally poor design decision to annoy my students. That's you. You're the students. Okay. Let's run this code. Before I run this code, I should note there are 2 scanfs. This means I have to type in things twice, or I'm going to get either a segmentation fault or an infinite loop. So I'm just going to do that. We don't need to debug this right now. Debugging codes is for cowards. Just deploy live to production without a test. This is not a software engineering class. If I showed you my GitHub pages, there is a line straight from build to deploy. There is nothing in between them. I live without fear. Oh, thank you. I do my best. I owe so much to my fans, and so I'm going to type in a number ft, a number dot, a number in, and I'm going to do this twice, but it's going to tell me what to do. And then I'm just going to print them back out directly. Four, 6 inches. That's how scanf works. don't mess around with it. That's weird, right? Initially, naively, I'm just returning the original foot directly. So we can fix this, or we can implement it more properly, right? Wait, why am I gecking on one of them? Do you all call it gec?
What is it?
GCC? I prefer gecs because there's 2 C's, right? And then if you compile 100 times, it's 100 gecs, right? Okay. We can add this up. Wait, this is supposed to be an exercise. Oh, you should do this. Do you want to do this, or do you want to watch me do it? Why do you want to watch me do it? It's 9:30? I'm so hyper for 9:30. There's something in this seltzer water. I've been slamming these seltzers. If they're supposed to be 0 calorie, I feel like I've been just chugging sugar. All right. I don't know why I signed myself up for this. Okay. Weren't you all the ones that signed up for a program that had classes until 9:30?
You signed up for a program that had classes until 10.
Okay. So I'm going to set buff2 equal to, let's see. Oh, this is an adder. Oh, addition's easier. We get to do addition. That's nice. We're going to see how tall the average man is while A.J. Wilson is standing on top of him. Presumably at like a sick dunking contest or something, right? Okay. Buff5 plus buff2. No, we're going to do 2 then 5. What corner case do I have to deal with here? Well, I can be 5 foot A and be standing on top of someone that is also 5 foot A, in which case our height is not, what's 20 in hex? 14. Okay. So I have to do a carry check. And so the way I'm going to do this is I'm going to use modular arithmetic in a cryptography class. Ah, I'm so fun. Okay, so I'm just going to take that mod 10 because I'm only looking for the lower order bit, right? Buff 1, which is the next one over, this is the non-decimal thing, is going to equal buff 1 plus buff 4. So I'm also going to add the carry bit. What is the carry bit? Well, I can calculate the carry bit using the integer division. 2 plus buff 5 divided by 10. Why did I do Python division? Okay. This thing is equal to 1 if there's an overflow, right? It's also equal to 2 if there's an extreme overflow, if I'm adding 3 heights together. So that's the carry bit, or the carry value, or the carry digit. And then these are the heights in inches. So this is the heights in inches, and this is tenths of inches. So we add inch plus tenths divided by 10. There should be a lot of parens here.
Is this basically the framework for how we can do big math?
Yes, this is the answer key. It's base 12, right? Because if there's more than 12 of these, then I add a foot. I pressed enter by accident. I didn't mean to do that. Okay. Let's calculate our number of feet. So I like to tell my cat it's very odd that she has 4 feet, even though she's not even 1 feet tall. She loves this. Buff 0 That's going to be the number of feet, which is the number of feet of the person upon whom is being dunked, plus the feet of the person whom is doing the dunking, plus this thing. Oh, how do I, no, I'm not going to use the mouse. Okay, I need to yank. So I think I get out of insert mode, I press Y, and then is $sign the end of line? I have not been using Vim. Oh, not in insert mode, okay. Okay, that worked. So that was a yank and paste, and I think it's so stressful using Vim in front of students. Indy, who's active in Discord, as you all know, like mercilessly ridicules me. It's great, because the purpose of life is suffering, right? So you get to suffer in the class. Okay, this is not %12. %12 is how many inches. We need how many multiples of 12 inches we have, because every multiple of 12 inches represents 1 foot, which is more than my cat has. Okay, so we're going to do a divide. It's an integer divide, the good kind of divide, right? And so perhaps this will work. Let's see. Does anyone have any comments before I run this? Do you want to feel very clever? If you see any bugs in my code, and there's like a lot of code that has bugs in it there.
I think your parentheses may be on that the buff one, where you have parentheses, 3 open parentheses and 2 closed parentheses.
3 open, 2 close, right? So I need to lose 1 here, right? And then 1.
I think just 1 there.
Oh, not an insert. Well, okay. Oh, that was more than I meant. What's E do? Oh, that's the end of word. Okay. That's fine. And then, oh, 2 open, 2 close. Because I yanked that, yeah.
We'll see, I guess.
Yeah, I know it's fine. Did I save that? Four feet to 5.6 m. That's pretty cool. Is that correct? Like, it looks extremely wrong, doesn't it? Because isn't 2 plus 5 7?
Did you do 5 with 7 point values?
Yeah, you would think that, right? Oh, I might be typing things in wrong. What? Okay, that's telling us something, so the error is here, right? Okay, I see it. This value should be inside parentheses. And that value occurs twice. That's why the error was in 2 places. Which is why you should never copy-paste your code. What should I have done? Written a function. Software engineering, right? Code factorization? Yeah, everyone likes to factor code. Code reuse, reduce, reuse, recycle. It's good for the environment. Okay. Actually, no, I should have copy-pasted code twice, because if I copy-pasted the original code, the friends are on that line. So you should always copy-paste your code. Okay. If there's anything I learned from writing Lisp, you should just always add a bunch of parens, and at some point your code will start working. How am I hitting shift? Okay. Oh, we didn't fix it. Wait, I didn't compile. Okay. I should have picked a less tedious example to type. Yes. Okay. But what's a fun thing to do? 1 foot 1.9 inches, maybe. Oh, I wonder what's going to happen next. Okay, let's see what's going to be on that. 1 foot 1 dot. What's everyone's favorite number that's between 2 and 9 inclusive?
5.
That's a good choice, because it's in between 2 and 9 inclusive. Okay, and then we write the in for inclusive. Right? Is that what was supposed to happen?
No.
Oh, is that wrong? Oh, did we not carry? The 4 is correct, right? I don't know. Oh, right, yeah, this is supposed to be 3, right? That's the bug? So the bug has to be in this line?
Is it because you have reassigned buff 2 previously, so it's right?
Yes. There's only one possible solution here. We have to create a carry value, which we'll store in buff 6, which we're not using yet. Okay. Can we even do that? Does that help? Okay, yes, all right. Buff 6 equals escape y $, up, paste, switch back to insert mode. Okay. So I think buff 6 holds the carry value, which means I can come down here and replace, I don't know how many of these there are. Okay. Vim is so scary. It's like I feel alive again. Okay. Do you know what I should do now? I was trusting you.
Well, if you make something nice, just put it in there. But then you have to do the same thing for that 4th line, because you're reassigned that one as well.
I have a plan. I'm going to steal another 32 bits while no one's looking. Okay. This needs to be in parens, right? Okay. Blank, paste, insert. Okay. And I'm going to use carry bit buff 7, and this is divide by 12. Then I'm going to delete the rest of this line and just add buff 8 or buff 7, right? And this is bad enough code. I'm going to write myself a comment so I know what's going on here. Carry. I'm so used to calling them carry bits. They're carry digits. And then this is a carry digit. I think there's an off chance this is going to work, right? Right? Can I hear it for, well, no, let's see if it works first. I think this was our answer. We had 1 foot, 1.5 inches, maybe? Is that correct? It looks correct.
That's correct.
Can I get a whoop whoop? Thank you. Yeah, it was very emphatic. Okay. Did I use all of these libraries? I don't think I used all those libraries. I don't know if they're all just...
Standard gives.
Yeah. Look at that beautiful Discord syntax highlighting. It's practically GitHub. Okay. That's the exercise. This is the only time I have called out a programming language in my life, but I felt really good about doing it, so that was fun. An astute student will now notice that you can implement your own arbitrary precision integer library, which shockingly is this week's homework. What? Okay. An astute student may also have noticed that probably addition is easier than multiplication. I'm going to say this to make sure I don't run out of time. I found implementing big division really, really hard. I wrote a lot of scripts to test it. I wrote a lot of interfaces to test my script. I tested it against both GMP, the C language, and against Python, and I had to use all of these processes to get my code to work, and it still took a long time. This is a good thing. Why is this a good thing? Next week, I'm going to implement the RSA algorithm, and the entire basis of RSA is that specifically factoring is hard, but division is hard. Given a number, it is very difficult to determine what numbers divide that number, right? And I've taught this before, and students say, what do you mean division is hard? It's one of the 4 arithmetic operations. Those are all exactly as easy as each other. We learned division in elementary school. And then I say, what is this 2,000-digit number divided by this other 2,000-digit number? And they're like, I actually don't even know where to start, right? I knew division was harder actually from my limited background in electrical engineering, where at some point in my life I figured out I could solder together a circuit that could add, subtract, and multiply. And not only could I not figure out how to implement divide, but I looked at the answer key and still didn't understand it when I had the solution in front of me. It was like the difference in difficulty between division and the other 3 operations, because multiply is not actually that hard when you realize some tricks to it. It is unbelievable. Separately, it is also the case that literally no one has solved this, and in fact, modern devices, division is just slower than other operations. It just takes your computer longer. At this point in time, you'll realize there were no multiplies or divides in SHA 256 anywhere. Every modulo just happened with overflows, which are free, right? So I would like you, okay, so first of all, if you successfully write multiply, like, you are not going to have a hard time writing code again. Like that, I just don't think that's going to happen, right? The amount of information I had to keep track of in my mind was pretty incredible. I suspect the way that people that actually know how to do this use it is you use object-oriented and you do encapsulation somehow and you implement a type. And it is not that bad if you do all of that steps. If you just try to write an imperative programming language that writes divide, there's just like a few too many off by 1 errors. If you happen to get it right on the first time, which will happen at, I think, like medium probability to some of you, like good for you, I'm sorry that it ruined the assignment for you, right? Look at it, think about it, understand why it's hard. If you don't get it, we'll backline onto the GMP built-in library, and you can keep doing the rest of the class based on that library, right? I have carried through into the future weeks, making sure that you can use, well, I have the variant I wrote, which I expect to be low performance. I haven't performance tuned it yet. I haven't measured how fast it is yet. And then I'm also backlining onto GMP, so I'm making sure everything goes through regardless of whether you can get division to work. And separately, maybe you get multiply to work but not division. Awesome. That's also good. So anyways, I don't have a single student, and this is the first time actually an assignment has been assigned before 1 student finished it, because I have a few overachievers, unless one of you has done it. But to my knowledge, no student has successfully done division yet. I think most of my top most motivated students are progressing through multiplication and likely to finish soon. I don't know how hard this will be for other people. It was really hard for me, and I really enjoyed working on it because I like working on hard things. Get multiply. Multiply is achievable. It is within your skill set. It is consistent with the difficulty of SHA 256. Okay. FAQ. Can we use this to add numbers bigger than 2 to the n using adds over at most n bits at a time? Oh my gosh, you can. I think someone already asked that. See, that was the frequently asked questions. You now have big add. Sure, change the modulus in the set. Can you do this for more than 3 fields? Yes. Right. So once you've seen the carry bit, that generalized solution, my add and subtract have something in them called carry. And I think I return it at the end in case you have an overflow, this measure overflow. Easy. Okay. Let's talk about multiply real quick. I don't even have slides on divide, but here's a motivating example. This is hard to imagine, but imagine there are 14 MS level computer scientists, which is how many students I thought was in this class, which is why like when 7 people showed up, I was like, that's a significant estimation error. But in fact, maybe this is all of you, I don't know. Okay, so imagining an engineering team lead for, that's us, we are the engineering team lead, and we have 14 MS level computer scientists that work 9 to 12 hours a week on this assignment based on the credit hour policy. Okay, and you have a 14-week contract, and you have 34 BS level computer scientists that work 69 hours a week on a 15.5-week contract. The undergraduate semesters are a little bit longer because they have 2 a year. And in fact, there's 1 week a year where we're teaching the last semester or last week of undergraduate at the same time as the first week of graduate, and our heads explode. It's great. How many person hours is this? So some of you have probably heard of the famous management theory book, The Mythical Man Month. And in it, I think it contains the expression that if it takes 1 person 9 months to have a baby, you should be able to have 1 baby in 1 month with 9 people, right? Which no one has successfully demonstrated yet. And that's why I'm not a software engineer. Okay, I'm going to demonstrate how fast we can produce a satisfying SHA 256 assignment if we each write 1 line of code, and then we will combine all of the lines of code with a map reduce operation. 12 times 14 times 14 is a little bit too easy, so I performed some initial mental math because I want to persuade you that not only can you look at the outcomes of your big mole and realize that it's wrong if you multiply 12 by 12 and get 4 trillion, but also that this can solve problems that are really hard, like 12 to the 16th, which I don't know what that is, right? So 12 times 14 is 144 plus 24, which is 168, and it's easy to check that that's correctly because that's 12 times 4, and 168 is the number of hours in a week. So that's how many hours I spend a week writing C89 code. 9 times 15.5 is trivially 155 minus 15.5 because it's 1 less than 10 times 1. So that's 139.5 hours. I put this out on a table like so, and I proceeded digit-wise. I want to point out something with this digit-wise table. What I expect to be the hard thing with big multiply is keeping track of the precision. And what is the precision? That is how big these numbers are. We know what 5 times 3 is, but we have to keep track of whether that 5 times 3 represents 15, 115, 150, or 1.5. So we can naively conduct all of these multiplies, and in my case, I conducted these multiplies by taking a large stream of 4096 bits, chopping it into chunks of 32 bits. Why? So that I could use the built-in 64-bit multiply, which can definitely store things of size 2 to the 32 times 2 to the 32. So I multiplied my two 32-bit chunks by each other, got 64 bits back, and then I added that to the correct portion of my output register. Now, the correct portion might not be 64-bit aligned because I'm working with 32-bit chunks. So there was a ludicrous amount of overhead here, and this is where all the off by 1 errors came from. This slowed my code down, or slowed my code development process down. I think my code is fast. It seems okay. The reason I emphasize that these are not single-digit values is that in the decimal number system, when we multiply any two numbers of 1 digit in size together, we at most get something that is 2 digits in size, which we can see trivially by taking the two largest single-digit values, 9 and 9, multiplying them together and getting 81. So that is our ceiling. This exact same process is true of the 2 to the 32-bit values. There is no two 32-bit values I can multiply together that do not fit in a single 64-bit value. Dealing with overhead is hard. I saw some students that were using 128-bit extensions for this, which is pretty interesting because I think those don't work under C89, which means they won't work in the auto grader. But if you figure out a way to do things 128 bits at a time, be advised you have solved no problems, because this is exactly as hard to think about no matter how you divide up the bits. In fact, you could just as easily do it 8 bits at a time. I don't care. The only reason I did 32 is I wanted any vague semblance of performance at all in case I ever actually got this to work. I included significance as well, which made this a little bit easier to think about for me. So that 3 is now 30 and that 1 is now 100. This still has the benefit of only having 2 non-zero digits, but it also preserves how big the digits are. This is basically reintroducing the notion of scientific notation, right? So I'm just taking a potentially 2-digit value and multiplying it by some power of 10. I demonstrate that over here, and I demonstrate the powers of 10 as well. What is the annoying whistling noise? I feel like, yeah. I don't feel like we're going to get a lot done in the last 5 minutes of class while that's going. I'm going to show you this slide. You can convert all of these multiplications into polynomials. I don't know if you're super jazzed about multiplying polynomials together, but you can factor out 2 to the 32. I factor out powers of 2 all the time. That's how I'm always doing the estimation of how many bits I need. I factor out thousands. You know how to do all of this. I claim that this was covered in either 7th or 8th grade when I was going to school. Apparently, since then, I was talking to a colleague, and public schools don't have school on Thursdays or Fridays anymore, which is a very large number of the days. So anyways, I stopped making assumptions about my incoming 19-year-old's level of mathematics preparation a few years ago, and that's been necessary but strange. They're not super good at multiplication anymore. So I'm assuming you can all still do multiplication because I think you all went to school when I did. But also, you don't want to assume people went to school in this country, though usually that doesn't matter what country you went to school in. It is natural to express multiplication of 4,096-bit integers as a polynomial over 64-bit integers. Here's the techniques I used. I think we're done. I cannot focus with that whistling going on. Do you have any questions?
Where are we implementing multiplication? Is that one of the homeworks?
Mm-hmm. It's the 409060 homework.
Oh, it's 409060.
Mm-hmm. I named it that, so it was going to be, most of the time when people do this, they do arbitrary precision, and you're doing exactly 4096-bit precision, because we have this, it's another one of the hidden learning objectives, which is memory safe code. So knowing exactly how many bits you're going to use is cool. And I'm going to show you the alternative to knowing how many bits to use after break. But you can actually solve this SHA problem, or this RSA problem with fixed size, which is cool. This is the last thing I'll show you. This is a technique. I take an array of 64-bit values. I lie to the compiler, and I say it is an array of 32-bit values, and then it is 128 32-bit values, and I can reference any 32 bits of it at a time. It means I can pop out 32-bit chunks and multiply them together, get a 64-bit value, and put it in my solution key. So this is an example of how to do that. Last thing is, I thought I fixed that thing. I did not remember how to do long division, so I just taught myself long division from Wikipedia, and it was fun. And then there was a lot of corner cases, but all of the corner cases were things you know how to do. Oh yeah, closing thought. This one was unexpectedly hard. You can't return 4096 bits from a C function because there's no type of that size. The way I would like you to solve this for two reasons, this is a good way to think about electrical engineering, is you actually have a function with three operands. There is the two numbers that you're adding or subtracting or multiplying together, and then you provide the location where 4096 bits live. This function performs the operations and writes the answer here, and then it returns either nothing or yes or a carry bit, but it does not return all 4096 bits. The way this works is it alters what happened in these 4096 bits. So before I call big add, I declare three variables that are each 64 bit values, so 4096 bits. I load some information into the first two, and I do nothing with the third. I call the function, and then, while this function is running, it sets values within the third of the variables, and then I have the solution to the arithmetic operation in this variable named sum when I am done. This is the same as writing to a data frame. People do this in R all the time and find it unremarkable. So we're essentially performing a mutate on sum. This seems hard to people and I don't know why, so just ask me questions if you're confused by this. And you can ask them in Discord if you don't want to ask them right now, because it's the middle of the night. It sounds like a vacuum?
It might just be a vacuum.
That's a vacuum.
They could be vacuuming the lobby, they could be vacuuming the basement.
They're vacuuming the rooftop terrace. Yeah.
Makes sense.
See you next week. No midterm. If you happen to find big division easy, do not tell your classmates, but tell me. If you find it hard, say, wow, this is hard, so we can all commiserate together. Oh yeah, here's the thing about memory safe code. You have to find a wayback.com archive of a White House press release, which is the funniest way to ever argue for what your implementation decision is. It's like, no, you have to go to the web archive, right?
Well, because they nuked the entire White House website on Inauguration Day, which